Good morning, everyone. आवाज
सर तुमचा बंद करा.
चला
आवाज 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 आवाज
बंदच कर. बंदच कुठलं?
तुम्ही एका आवाज 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 तुमचा
Good morning, everyone.
तुमचा तुम्ही बाहेर जाता तसं ऐकून नाही जात कारण त्याचा आज इकडून परत रिपीटेटिव्ह फाईल लागतात.
Good morning, everyone. येत आहे का सर? हे या नाही येऊन राहिलं का?
सर तू इको नाही झाला पाहिजे. का बरोबर इको?
आता बरोबर आहे. कंट्रोल वरतीच पाहिजे. हा कंट्रोल वरतीच पाहिजे.
बरंच करा. हा सर तुम्ही आता बोला.
Good morning, everyone.
कंट्रोल वरतीच पाहिजे. तुमचं ते सुरू आहे स्पीकर.
माझा
आता सर युअर इंटरनेट कनेक्शन इज वरती आणि सोनारे सर वगैरे इंट्रोडक्शन साठी खाली होऊन जाते. आणि मला जे इंट्रोडक्शन द्यायचं ते मी तिथे देऊ शकतो.
Hello, everyone. Good morning to all.
मला मी बंद करून ठेवलं. नाही नाही
सर प्रोफेसर झाले
मी काय करू?
हे बंदच ठेवलं.
ते आता होस्ट जवळ आहे काय होस्ट सगळे हे करतो.
इकडे बसू नका.
इथं काहीच नाही आता. सर इको येत आहे का पहा. हॅलो एव्हरीवन, गुड मॉर्निंग टू ऑल. जितेंद्र सर, is there any echo?
येस सर, क्लिअर आहे. बट साईडचे मोबाईल जे आहेत पूर्ण सायलेंट मोड वरती पाहिजेत.
हो, बाकीचे सगळे मोबाईल सायलेंट वरच आहे. जितेंद्र सर,
येस सर.
जर आपले याच्यातले हे असतील रघुवंशी सर, लाड सर आणि हे जर असतील वेटिंग वर, त्यांना जॉईन करून टाका.
येस सर, येस सर. ते खाली झाले, हे आले, ते तिसरं सांगायला, दुसरा आले, दुसरा सांगायला. मला इन करा ना, मला इन करा ना. आता
बाकी सगळे म्यूट करून टाका सर. नाही तुमचं
हॅलो.
हा,
करतो आता. माझं जेव्हा सुरू करायचं तेव्हा मी अनम्यूट.
म्यूट करू.
सर, आय थिंक आता सगळं व्यवस्थित आहे.
Now everything is clear. Dr. Jitendra Kausalya, am I audible for you?
येस सर.
जितेंद्र सर, कोण कोण जॉईन झालं पाहून घ्या बरं एक. अभ्यास इगोर जॉईन झालेले आहेत. लाडसर अजून जॉईन व्हायचे आहे. रघुवंशी सर जॉईन व्हायचे आहे. आपले कातेड सरांना जॉईन व्हायचं आहे.
Hello, do you see me?
Yes,
Can you
sir.
hear
Yes.
me?
Yes, sir. You are clearly visible.
Okay. And I don't know how I can demonstrate. how to check the screen? What have I do?
You are clearly visible and you are clearly audible too, sir.
You have my. You have my. Okay.
Sir, you want to
Okay. I try, but it is not my time yet. Yeah, we have to wait.
Yes, sir.
अमित सर तुमचा वेळ आहे का?
अमित सर, एअरडो तुझ्या कनेक्ट आहेत का? ब्लूटूथ बंद करून टाक. मग अजून कोणाला कनेक्ट केले होते? जितेंद्र सरांना. जितेंद्र सर,
yes sir.
एअरडो तुम्हाला कनेक्ट आहेत का?
No sir, no.
तुमचं ब्लूटूथ चालू वगैरे असेल.
नाहीये सर. असंही you can audible to all.
ओके.
I think we can start.
Can start? Okay. Should we start? Raghuvanshi. Sir, let's wait for 5 minutes. Check. नाही.
Okay.
म्यूट केलं तर चालतंय.
Sir, Raghuvanshi sir are in.
Okay.
Now
Let's
they have
start.
joined.
Am I audible to all?
Yes sir.
Okay. So let's start. A very warm and good morning to respected dignitaries, invited guests, galaxy of intellectuals, distinguished delegates from all over in India and from other countries, and my dear colleagues. I, Dr. Dhananjay P. Deshmukh, Assistant Professor, Department of Physics, feels honored to welcome you all on behalf of late Rajkamalji Bharti, Arts Commerce, and Srimati Sushilabai Rajkamalji Bharti, Science College, Army, in international webinar on recent trends in physical and mathematical sciences. I feel privileged to welcome Honorable Dr. Sanjay Rajkamalji Bharti, President, Shri Datta Prasadik Shikshan Prasarak Mandal, Army. Honorable Advocate Siddharth Sanjayji Bharti, Secretary, Shri Datta Prasadik Shikshan Prasarak Mandal, Army. Honorable Dr. R.M. Tated Sir, Principal, late Rajkamalji Bharti, Arts Commerce, and Srimati Sushilabai Rajkamalji Bharti, Science College, Army, District Yavatmal. Again, it gives me immense pleasure to welcome Dr. F.C. Raghuvanshi, who is Dean, Faculty of Science, Santa Gadge Baba, Amravati University, Amravati, and Dr. A.B. Lad, who is Chairman, Board of Studies in Physics, Santa Gadge Baba, Amravati University, Amravati. A very special welcome to the Dr. Igor Nesseru, Institute of Hydromechanics, National Academy of Sciences of Ukraine, from Ukraine. Dr. Abdul Hakim Deshmukh, School of Chemical Engineering and Light Industry, Guangzhou University of Technology, Guangzhou, China. Dr. G.G. Mule, Head, Department of Physics, Santa Gadge Baba, Amravati University, Amravati. Dr. K.S. Nisar, Professor, College of Arts and Sciences, Wadi Aldavazar, Prince Sattam bin Abdullahi's University, Kingdom of Saudi Arabia, Saudi Arabia. I again welcome all the eminent speakers, guests, and delegates from all over the country and outside country on behalf of organizing committee. Before starting, here are some housekeeping items. I request all the attendees to mute their cell phones. If you have any queries during presentation, please type into the question box in your Zoom control panel and chat boxes. Filling of the feedback form is necessary. Friends, we all know that COVID-19 is a pandemic privileging all across the world past few months. Every day, it seems to reach a new and tragic milestones. Every day, we are learning more and more about the viruses and the diseases it causes. But here, world will not stop. Sir, we all know that physics and mathematics are two closely connected fields. For physicists, math is used to answer exact solution for the query. And for mathematician, physics can be a source of inspiration with theoretical concept and significance. By keeping this in mind, we have chosen our topic, recent trends in physical and mathematical sciences. So to start with, I feel very pleasure to call Professor Milind Pandey, IQAC Coordinator, late Rajkamalji Bharti Arts Commerce, and Srimati Sushilabai Rajkamalji Bharti Science College, Army, to say few words. Over to you.
Thank you. Thank you very much. Good morning, friends. I am M. Pandey, IQAC coordinator of the college. Feel very glad to welcome the president of Sri Datta Prasadi Shikshan Prasarak Mandal Arni, Dr. Sanjay Ji Bharti, the secretary, Advocate Siddhartha Bharti, the principal of our college, Dr. R.M. Tated, all the honorable guests, lecturers, dignitaries, and the participants in this particular international webinar organized by Physics and Mathematics departments and IQAC. The topic of today's webinar is recent trends in physical and mathematical sciences. Friends, I am happy to tell you that our college always takes initiative in various social and medical issues. After March 2020, in the lockdown period also, we organized COVID-19 awareness programs. We provided masks and PP kits to the police stations, doctors, nurses, masks to the grocery shops as well as saloons, organize blood donation camp as it was appealed by the Maharashtra government due to the lack of blood in the state. Our president organized this camp in our college few days ago. And I am happy to tell you that almost 100 people donated the blood in this particular blood camp. We also organize various programs related to social issues in our college, organize webinars. In the last few days, we organize the webinars on various subjects by various departments, especially English, Marathi, that means language departments, botany, zoology, sociology, political science. And today also, we are all here in the particular international webinar. Being the coordinator of IQSC, I wish you all the best and a good day ahead. Thank you very much.
Thank you very much, sir. Thank you very much, sir, for your appreciation. May I now request our beloved principal, Dr. R.M. Tated, sir, of late Rajkumarji Bharti, Arts Commerce, and Srimati Sushlabai Rajkumarji Bharti, Science College, Arni, to address us. Over to you, sir.
Good morning, friends. Myself, Dr. Rajendra Tated, the principal of late Rajkumarji Bharti, Art Commerce, and Same Sushlabai R. Bharti, Science College, Arni. Welcome you all in the international webinar on the recent trends in physical and mathematical science organized by Physics, Mathematics, and IQAC. Friends, our college was established in 1984 with 2 faculties, Arts and Commerce, and then we started Science faculty in 2009 under the leadership of our President Dr. Sanjay J. Bharti, Head of the Department Orthopedic Department at Government Medical College, Yavatmal. The main purpose of starting Science faculty was to give the girl students in our area an opportunity of studying graduation in all the faculty. We also faced NAC in 2016. Successfully, our college takes initiative in many social activities like blood donation, medical health checkup camps, women empowerment program, and other awareness program. Our social problem, our college also organize many workshops, seminars, and conferences. Today, also we organize an international webinar on recent trends in physical and mathematical science. Being the principal of the college, I feel very glad to let you know that though our college is in rural area, almost 800 participants from all over the world joined this webinar. So I am grateful to all. I again welcome you all and wish you all the best and good day ahead. Thank you very much.
Thank you very much, sir, for your wishes. Now, I request Dr. F.C. Raghuvanshi, sir, who has taught me and students like me, and I am very appreciable to him. I request who is Dean, Faculty of Science, Sant Gadge Baba, Amravati University, Amravati, for his inaugural remarks. Over to you, sir. बागडे सर. Raghuvanshi sir, honorable sir, your microphone I think is muted. Okay, thank you sir.
Thank you, Dhananjay.
Thank you.
Chairman of today's inaugural function, Dr. Sanjay Ji Bharti, President, Sri Datta Prasadak Shikshan Prasarak Mandal, Arni, Chief Guest, Dr. A.B. Lal, Chairman, Board of Studies in Physics and Professor and Head, Department of Physics, Amalak Chand Mahavidyalaya, Yavatmal, Guest of Honor, Advocate Siddharth Ji Bharti, Secretary Sri Datta Prasadak Shikshan Prasarak Mandal, Principal of the college, Dr. R.M. Tated, Convener of the webinar, Dr. Pramod Wankade, Dr. Varghese, IQAC Coordinator, Professor Milind Pandey, all the resource persons, delegate and staff member of the college. It's my great pleasure to be with you for the inaugural function of international webinar on recent trend in physical and mathematical sciences. Dear friend, I congratulate the staff of physics and mathematics department that they have selected a very good topic. As Dhananjay expressed that these two sciences are correlated with each other. You cannot imagine physics without mathematics or mathematics without physics. The mathematics is the backbone of physics. It is happy to note that this college is doing for the social benefit, the activities for the social benefits like awareness program of the COVID, distribution of the mask, blood donation camp, and many more. Dear friend, today we are living with the COVID-19. It has affected our day-to-day life. Almost all sectors all over the world are badly affected by COVID-19. The term COVID positive creates fears in human mind. It has changed our style. We have never used masks, but now we are with masks. It has changed our tradition, our culture, our teaching method, our examination pattern, and many more. No doubt, COVID positive is not good. But in my opinion, COVID positive has some positive side. It has given opportunity to us. In India, we don't have sufficient facilities like hardware such as desktop, laptops, smartphone, the bandwidth of the internet, etc. In such odd conditions, we have adopted new techniques We have adopted the technique like online teaching, learning, online examinations, and most important is we are contributing for the development of e-content. We are conducting webinars with the help of these techniques. In past, we have organized the conferences or seminars physically. But it is difficult to organize such conferences in a rural area like Arni, because the resource persons and delegates are not ready to come this place. We don't have sufficient funds, even the infrastructure facilities, and therefore it is difficult to organize the such grand functions, international conferences, seminars. This college has started the science faculty since 2009, and in science faculty there are young teachers, and this young teacher has trapped the opportunity of COVID-19, and they have organized a international webinar. It is very difficult to organize this such type of international webinar. I therefore congratulate the staff member of physics and mathematics, as well as I congratulate the management and principal. The role of management is very important. Without their support, the staff of the college cannot organize such big functions. In last decade, technology is changing very fast, and due to new technology, the colleges which are situated in rural area and remote places can organize the such activities. Dear friend, research play very important role in higher education. The higher education provide basic to the research, whereas the output of the research update the higher education. Thus, research is integral part of higher education. We must consider research as one of the components for higher education. I know that today's generation is very smart. This generation is fertile. If they get proper guidance, training, and environment, they can give quality research output which will useful to the society and which can fulfill the need of the society. The need of the society is necessary because the research which is not useful to the society, which is limited to the paper only, then what is the use of this such research? Such conferences, such webinars can motivate the young researchers to carry out their research. But to get the proper output, research should be carried out in a systematic manner. If your research is in a systematic manner, then only you can give very good output. To start the research, you must identify your field of interest. It is my observation that the researcher never show the interest in the field of his interest in a particular field. He select the topic given by the supervisor, and hence he does not have any clear idea. Therefore, the interest of the researcher is very important. Second, you have to identify the need of the society. If you know the need of the society, then only you can carry it out in a particular field. And most important is, I have thought to carry out the research, but I don't have sufficient infrastructural facilities, sufficient fund. You have to consider the fact, all these factors to select to select your research topic. On these factors, you can select your topic, and to select a proper topic, you have to carry out literature review. The analysis of literature review can give the idea at the basic to select the topic. And once you select this topic, you can start your work. Dear friend, the output of the research, after completing some part of the research, it will give the output. This output must be published in a quality journal. A journal having high impact factor. Generally, it is observed that even though the work is quality, it is published not in a quality journal, and therefore it does not give any impact. It is not useful to the scientific society, and hence it is important to select a proper research journal. Second step in this, the publication is not sufficient, but the research output must be patented you must file the patent, publish the patent. There are number of patents, but these patents are not converted into product. It is necessary that if it is a patent, if it is useful, then this patent must be converted into the product, and the product which is useful to the society. In the world, there are different material. These material play very important role in the development of the technology. Nature has given a different material having different property, and we have different need. As per our need, we can select the material. Sometimes we have to modify the properties of the material. This is the same thing as that of personality development. For the personality development, you have to undergo some training. For being a human being, that it is must. Similarly, in order to achieve some properties in the material, you have to change the properties of the material. The properties of the material can be changed by combination of two or more materials, or by adding small quantity of impurity in the host material. Such method can change the properties. Even a synthesis technique, a synthesis parameter, preparative parameter can also change the properties of the material. And by using this, you can tailor a particular property of the material. By using this, we can get a new material. It is observed that the properties of the bulk material may be different than the nanomaterial. Actually, this concept of nanomaterial is not new for us. In Ayurveda, we use the term bhasma. The bhasma has different property than the bulk property. Thus, we can develop such material as per our need. This material can be used in a smart devices. The devices, a single device which can perform number of operations, and such device can be called as a smart device, like a smartphone. Dear friend, the organizer has invited various resource persons for this webinar. This webinar will be definitely provide platform for budding scientists. They can share their thought, their innovative idea with the resource persons and other delegates. I am sure that this webinar will provide a solutions to the problems of young researcher. They will get new directions, new thought, as well as motivation to carry out a quality work. I am confident that this webinar will provide a huge momentum and motivation to carry out research work. It's my honor to declare that this webinar is inaugurated. I extend my best wishes for the grand success of this webinar. I thank to the organizer for giving me this opportunity and to share my view with you. Thank you. Thank you very much. Thank you, Dhananjay.
Thank you very much, sir. Sir, it's not your honor, it's our honor that a person like you has got the inaugurator to us. Your ideas are really inspiring us. Since from the older days to new ones, you are the pillar of new generation. And your guidance, we hope that your guidance will get her in long time future to us. Okay, thank you, sir. Now, I request President of Sri Datta Prasadik Shikshan Prasarak Mandal, ARMI, Honorable Dr. Sanjay Ji Bharti, who has opened new horizon of higher education in the form of science faculty in 2009. I request him to guide us, to address us. Over to you, sir. Honorable Dr. Sanjay Ji Bharti. Over to you, sir. Over to you, sir. Honorable Dr. Sanjay Ji Bharti, President of Sri Datta Prasadik Shikshan
Excuse me, sir.
Prasarak Mandal.
Sir, please unmute yourself. Bharti,
Yes,
sir.
our beloved President, Dr. Sanjay Ji Bharti. President Shri Datta Prasadik Shikshan Prasarak Mandal, Army. Over to you, sir.
Sir, we have to wait 1 minute. Sir had some trouble, I think, in to reach the sound.
It is, we are sorry for a moment. Our beloved President are ready to join our audio.
Sir, I think you have not unmuted.
Some trouble from audio.
Click on the button call via audio device.
धनंजय सर धनंजय देशमुख सर
Yes, sir.
सर my name Professor Dr. P. Reddy, sir.
Yes, sir.
Sir, how many sessions in this one day webinar? Can you tell me, sir? Up to what time?
Yes, sir. Actually, there are four technical sessions, 4 sessions.
In morning and timings, sir, timings. Can you tell me?
The time may shift for some 5 to 10 minutes in the front, but actually we are trying our much best to go on to the time, sir.
Sir, I think our president gets some trouble to reaching the audio. So we can move towards next session. Okay, next talk, please, sir. Dhananjay, sir. Sir, due to some technical problems, our president couldn't join. So we can proceed further. Dr. Deshmukh, sir.
Just a minute.
Hello.
Yes, sir. Yes, sir, you are audible.
Yeah.
President Shri Datta Prasadik Shikshan Prasarak Mandal Army, our beloved president, who has opened a new horizon for the science milestone. Over to you, sir.
Good morning, friends. Sorry, it is a delay. It was a delay of the connectivity. I myself, Dr. Sanjay Bharti, I am the chairman of Sri Datta Prasadik Shikshan Prasaran Mandal. Our institution has completed 75 years, and recently we have this stream of science stream having all the faculties. I am very glad that to join this webinar of common webinar of physics and mathematics. You all know we have a great glory of mathematics such as Arya, right from Aryabhatta, and all the renowned person are from India only. Similarly, so far as physics is concerned, the great person like C.V. Raman and all Nobel Prize winner C.V. Raman is light theory. You all know, so we have such a great scientist from India, and we are continue the same tradition here. I am very thankful to the principal and all the staff that they have taken this effort. Similarly, Wankade and his team and Professor Varghese and his team. We are already read due to this connectivity, and I will not throw or enlighten your specialty. But regarding COVID, I must say that the only treatment of the COVID is the social distancing. The second strain has been detected in England and now third in Uganda also. So these things are going, and further research is going on. So I think vaccine will be also not 100% proof. So the only take-home message is in COVID, we have to maintain the social distancing. Best wishes to all the participants and all the coordinators of this webinar. Good morning. Thank you. Thank you very much.
Thank you very much, sir. This was President of the Sri Datta Prasadik Shikshan Prasarak Mandal Army, Dr. Sanjay J. Bharti. Now, I request the chief guest of today's webinar function, Dr. A.B. Lad, who is Chairman, Board of Studies, Santa Gadki Baba Amravati University, Amravati, Physics, for his remarks. Over to you, sir.
Thank you, Dhananjay. Good morning, all of you. Today, Bharti Arts, Commerce, Science College, Arni, organizing international webinar on recent trend in physical and mathematical sciences in the presence of respected my mentor, Dr. F.C. Raghuvanshi sir, Dean of Science and Engineering Technology, Santa Gadki Baba Amravati University, Amravati. Honorable Dr. Sanjay Ji Bharti, President of Host College, Advocate Siddharth Bharti, Secretary of the Host College, Principal, my friend Dr. Tatel Sir, Pandey Sir, IPC Coordinator, Convener of the webinar Wankade Sir, Co-Convener Dhananjay Deshmukh Sir, Varase Sir, all staff members, all delegates, participants, my dear friends. Firstly, I am very thankful to the organizer to give me opportunity for one of the part of the webinar as a chief guest. On 22nd of December, we had celebrated birth anniversary of renowned mathematician, great mathematician, Dr. Srinivas Ramanujan. He has idea in the form of theorem in mathematics. We have to use in day-to-day life study. Yesterday, 25th December, we have also celebrated birth anniversary of great scientist and pioneer of physics, Dr. Isaac Newton. Everyone know these two builder of scientific educations. The role of mathematics and in physics very important. Both are just like a Brahma and Vishnu. One is creator and one is developer in the form of scientific applications. Mathematical simulations model is very useful tool for developing any scientific theory or interpretation in research of physics like condensed matter, astrophysics, material science, etc. The material industry trend range from solution for live weighting, 3D printing, and surface engineering, as well as in developing intelligent material, nanoformation, advanced compositions with enhanced characterizations, nanomaterial, crystal growth, thin film, quantum dots, superconductor, glass ceramics, ferroelectric, and new trend in double perovskite material for nanotechnology. These are the recent trend in the physical science for the device application like sensors, batteries, for farmer point of view, defense product, and most important in this pandemic situations is medical sciences. Now in these pandemic situations, know the importance of research in every field regarding medical science and medical industries and other industries for the job point of view. So I congratulate to the organizer for organizing international webinar, the rural place. Just Arni is a rural place and our district place, and provide new feed to the participants from the eminent resource persons. Best wishes to all. Thank you very much. Thank you very much.
Yes, sir. A friend like you will definitely help us to reach to the milestones in our life. Again, thank you, sir. Now, with the over of this inaugural session, respected colleagues, now it is time for the next session. I would like to request Dr. Vinod Varghese to have an introduction for Dr. Igor Nesteruk from Ukraine. Over to you, sir.
Yeah. Good morning to all on the occasion of this Boxing Day. We welcome Dr. Igor Nesteruk, sir, for the webinar. Really, on my personal note, I can say that Dr. Igor is a very nice and a great researcher. The name of a few which can be quoted on his behalf is that he is a lead researcher in the Institute of Hydrodynamics, Hydromechanics at National Academy of Science, Ukraine, and also the head of Laboratory of Biomedical Electronics. Going with his academic studies, he has earned his MS degree in Aircraft Engineering from Moscow Institute of Physics and Technology in 1977. He has done his PhD in Mechanics of Liquid gas, and plasma from Moscow State in 1982. Again, he has done a doctorate of science in the same subject in 2005. His main area of research are inverse non-study problems in fluid mechanics, super cavitation, flow control, and biomedical signal processing. In this regard, he has published a few near about 60 research papers and 2 books, and one of the book is it will be coming in March 2021. And near about 16 conference proceedings in which it has been published. He is master in 5 of the languages, that is English, German, Polish, and Russian and Ukrainian. Thank you, sir. Thank you for joining this webinar, and it's over to you, sir.
Good morning. Do you hear me?
Yeah, sir. Yeah.
Good morning. Thank you very much for invitation and very nice introduction. It's a big. I was in India, and it is for me an opportunity to travel to this country virtually, at least. I'm now in my flat in Kiev, and we have already night here, not yet morning. And I'm also, I think that there are a lot of physicists here, and I'm also physicist according to my education. But last year, I was very concentrated on the COVID investigations, and we can, today I will speak about this. I have sent, do you see, yes or not? Do you see the text?
Yes, sir.
Yes.
Okay, momentum. But I want to show next another one. This. An English one. There is the last, do you hear me? There is the last paper. It is available in internet on ResearchGate. I have sent to the chat the links, and it is a very important topic now, new waves of COVID pandemic, because now we can see that parameters of the dynamics changed, and new waves are occurs now in Europe, at least. I don't know the situation in India, but it is possible to probably it is possible to investigate also the Indian epidemics. And these new waves are very important to investigate as well, because many people are ill now, and we have a real large amount of cases, in particular in Ukraine. I have studied a lot of, have written a lot of text about the epidemic in Ukraine, starting from the first days when we have not so much cases, and compared, I have compared the situation in Ukraine with the situation in other countries, for example, our neighbors. And all these attempts are summarized in the book, which will be published in March in Springer Nature. And for this purpose, I have used, for example, SEER model, susceptible, infected, removed. And in these papers, in this paper, we have investigated the situation during September, October, November, and December. How looks this situation in Ukraine? We use only official data about the accumulated number of cases. There are official Ukrainian sources, 22, 23. Before we have used what World Health Organization reports, but in August they stopped to show daily information. We need daily information about new cases, because it is important to use the statistical method we have used. And the information looks like this. There is a day in the month, for example, September 1st, 2nd, and so on. There are some days starting from the beginning of the epidemic, usually, and in this table I use the starting day 20th of January this year. And there is a number of cases. Unfortunately, we have in Ukraine just now more than 1 million cases, but it is not all of them, unfortunately, because there are many cases, many infected persons are still not identified, since many people have no symptoms. For example, I know a lot of families where only one member of the family have done tests and was officially registered as infected person, but other members of the family have the same symptoms. They were in fact ill, but they did not make any tests and they are not in official statistics. And we have to understand this. Probably this situation we can have also in India, because at least in Ukraine we have such. I think for every infected person we have 2-3 more people which are not officially registered. And now about epidemic waves. What is epidemic wave? It means that suddenly situation changes and the dynamics also changes. And to detect this new situation, to detect period when we have another situation, we can use the observations about the epidemic, the development of the number of cases in time. But you understand that it is random variable. For example, in Ukraine, we have in different days of the week, we have different number of cases, and this random information needs some smoothing. For example, it was proposed to smooth the number of cases in such a way to use the weekly period, because, for example, in Ukraine, on Monday, we have always the lowest number of new cases, and the maximum we have on Friday, Saturday. And this number of cases smoothed, we can differentiate. We can calculate the first and second derivative and use this information to information about derivatives to detect the cases, to detect the situation when the parameters of the pandemic dynamics change. And when the waves are identified, are detected, we can use generalized CIR model. CIR, susceptible, infected, and removed. But it is not classical, generalized model. It means that we can use the model for every epidemic wave for this, for example, time periods, and to use classical set of differential equations, but here you can see parameters depending on I. It means that parameters are constant, but different for every epidemic wave. And as usual, S is the number of susceptible persons. There are persons who are sensitive to this pathogen, because not every person is sensitive. There are people who will never catch the infection, not only COVID, but also other infections. And people who are not protected, for example, people who are very far away from the epicenter, they are protected by distance, or people can be protected also by mask, but by avoiding visiting crowded places and so on. I is the number of infected persons, but who spread the infection. It is not the total number of people who were infected, have been infected, but people who are sick and spread the infection. And R is the number of persons who no longer spread the infection. This number is the number of isolated people, people who cannot spread anymore, people who are recovered and don't spread. Unfortunately, there are a lot of dead people. They are also removed. And also infected people who left the region, which we investigate. For example, who left Ukraine. And looking at the model, we can make some conclusions. For example, parameters alpha I, they can be, we have to make this parameter as small as possible in order to make epidemic not so severe and have not so much cases. And parameter rho I characterize the patient removing rate, and the inverse value is the average time of spreading the infection. And now we can analyze this system of equations. First of all, we have some constant Ni, it is the sum of Si and R, because if we look at the equations equation 4, 5, if we summarize, the result will be 0. Therefore, the derivative, this derivative is equal to 0, and we can conclude that the number Ni is constant. And in many books and in many articles, it is written that it is the volume of population. It is not true. It is constant parameter, but it is not the volume of population. For example, for China, these values was around 200,000-300,000, but not billion, not the population of China. And now we need to solve the differential equations, we need some initial conditions. At the beginning of every epidemic wave, Ti star, we have to know how many infected, how many removed, and how many susceptible people are there. And to continue, we can continue to analyze this system, obtain such, for example, such equation for I, And also we can calculate the number of susceptible people at infinity at the end of the epidemic, let us say. This value can be calculated from this nonlinear equation. And we can solve the system of equations with the use of, by introducing the function, the number of victims. There is the sum of infected and removed. We use V and call this value victims. And why it is so important to use this value? Because we cannot register the number of infected or the number of removed. We don't know how many people are spreading the infection at this moment of time. But we can see the sum of these values. This V, it is the number of cases, accumulated number of cases that we can use, and this number of cases is available. There is this number of cases. There are accumulated number of cases Vj shown in the table I have already shown to you. And there are realization of this, statistical realization of this dependence. With the use of this function, V, number of victims, we can integrate the system of equations. There are some details here, and obtain such results. It is analytical solution of the equations. For example, for every set of parameters, these parameters 5, and fixed value of V, we can calculate this integral. And then we can check how this we can obtain corresponding moment of time from this equation. Therefore, it is analytical solution, but in the form of integrals. And it is very important to have this solution because we don't need to waste a lot of time for integrating the initial differential equations. And for example, all my calculations were performed with the use of personal computer. I don't need super computers to calculate dynamics and predict how it will be. And after using these formulas 15, 16, we can calculate also S, R, we can calculate final numbers of victims, the size of the epidemic, how many weeks, how many cases we will have at infinity, so after a long time. And also we can estimate the final day of the epidemic from this equation, TIF, which is the final day. It means that we can take, for example, to calculate this value, the fact that at last day of the epidemic, the number of infected is less than unit, less than one people, less than one person is still infected. And it is a solution, mathematical exact solution of the set of equations. But we don't know the numbers, the values of parameters. And to calculate these values, we need some parameter identification procedure. This procedure is based on the statistic. we can calculate we can calculate because we have linear dependence. It follows from equation 15. We can calculate these parameters in this linear equation with the use of linear regression brackets. So very simple formulas for linear regression we can use. Use also moments of time, TG, and corresponding values of victims we can see from our statistics. We can use from statistical data, calculate then parameters of linear regression, calculate correlation coefficient with the use of standard formulas. We can also use the Fisher test to check how our hypothesis about the linear relationship between time and this function f, how it correlates with the statistical data, calculate this Fisher function, the value of this Fisher function to compare with the critical value, and with the use of some confidence level, and to make conclusions, are the results reliable or not. And there is some peculiarities which will be very good shown in the book, but now we can say that we can use some iteration procedure to calculate these values of parameters. It is shown here. And then for every values n, e, and mu e, we can find the the values which correspond to the maximum value of correlation coefficient. And it is the way of obtaining the optimal values of parameters. For we can just check all possible values of reasonable values of n, I, and mu I, and find the values which find the pair of these values which correspond to the maximum of the correlation coefficient or to the maximum of this ratio. There is the Fisher function divided by critical value of this Fisher function. There is theory. It is actually very simple. It is only differential equations and some statistical methods to obtain the optimal values of parameters, nothing else. And it's possible to investigate the waves of the pandemic and to make some conclusions. There is the situation in Ukraine after September 1st. These circles is the accumulated number of cases, the numbers from the table I have shown you. The line inside, there is the line, there is the smoothed number of cases. You can see this line. and triangles here. There is the first derivative. There is actually the daily smooth average daily number of new cases. It is multiplied by 100, therefore it is so big. To make it visible, I have multiplied this value by 100. It is written, and stars is the second derivative of this dependence. And we can see here some jumps in second derivative, here for example. And these jumps actually correspond to the new wave, because it means that something in dynamics changes and the parameters of the epidemic changed. For example, we can see this approximately in the middle of September, September 12, and it is very easy to explain because we have the academic year, the study in schools and universities in Ukraine start September 1st. After some incubation period, we can see this increase in the number of cases. We can see also these jumps here, for example, here in October. And it is also possible to explain why we have these jumps, because it was election and presidential pool in Ukraine in that time. And more than 30,000 places for voting was open, commissions, and many people worked at these commissions, and also it was advertisement, and it is evident that at this period of time we can have much more contacts as usual, and these contacts give us increase in the number of cases and new wave of the epidemic, actually. And fortunately, after November 25, the daily number of cases in our country decreases. Here you can see this. And it is, I don't know how it looks in India, but this wave, this increase connected with the academic year, with the studying in the school at universities, children and young people, they usually they don't have symptoms, but they transfer the infection. And a very interesting investigation was done in Ukraine. I will find the results here. Okay, then later. There are special investigations for staff in the schools and children garden. For 2 schools and 2 children garden randomly was chosen, and all the staff was checked for antibodies, and more than 60% of the staff had antibodies, but these people were not registered as ill persons. Therefore, they have got infection from children, and but they don't know that they were ill. Maybe they have some very mild symptoms. We have also a kind of weekend lockdown in November. It can also change the dynamics. But here we see the results of calculation for these optimal values of parameters. 4 waves, 6, 7th, and 8th wave. The numbers are calculated. Unfortunately, we will have more than 1 million. In any case, we already have more than 1 million, but it is unfortunately not the final. We can expect that, cannot expect the finishing of the epidemic before June next year. Maybe vaccination will change the dynamics, but according if we have the situation we had during in this period of time when the calculation have been done for this period of time. Then we have the finishing of the epidemic only in June, and there is some graphs for the dynamics in Ukraine. This red line is the 6th wave. We can see that it is rather good coincidence with the experimental data shown by triangles. After middle of September, there is a deviation. I told you it is connected with the beginning of the new year, of the academic year. There is this, then we have calculated the 7th wave. It is this black line, and corresponding values used for calculation are these circles. And 6th wave, this 8th wave, this blue line, and these circles points were used for calculations, and you can see that we have rather good coincidence. Only last days in December we have some discrepancy. Maybe it is connected with this lockdown of weekend lockdown, because these values were used from days when this lockdown worked, and now we don't have this lockdown, and it is some increase in the number of cases. This line shows the number of infected and spreading multiplied by multiplied by 10, and we can see that we have after December 2, 3, we have the decrease. Fortunately, we have the decrease of the number of people who spread the infection. And then maybe I have no time. We have to conclude that changes in pandemic conditions cause waves, new waves of the pandemic. We can see it in many countries. We can see these new waves in many countries, not only in Ukraine. I have calculated also some waves for world global dynamics. It is in the text I have told about. And these different waves can be simulated with this generalized CIR model, CIR model. And unfortunately, predictions are not optimistic, at least in Ukraine and also in the world. It will be next year, we will have pandemic in any case. The only way to change is to use vaccination. But we can do also many things ourselves without big without a big influence to the economy. It means that we have to minimize the number of contacts and trips, not visited crowded places, work and study remotely where possible. We have to refrain from shaking hands and kisses during meetings, use masks in transport in crowded areas, and if we have any suspicious symptoms, we have to do our best to avoid spread of the infection. And here I say thank you to many people who helped me with, who supported me and helped me with statistical information. And I think that it will be possible as well to make such kind of investigation with the use of Indian statistics, provided that somebody in India will be interested in such investigation, and we can do it together. Thank you for your attention.
Hello, thank you, Dr. Igor, for very well explaining the three compartment model, that is SIR, in a very logical and statistical way. Even I have published a fractional order SIR model on this and published in Innovative Biosystem and Bioengineering, and I have cited 2 of your papers. Thank you, sir. Thank you. Yeah, thank you, sir. And over to Dhananjay.
Maybe there are some questions.
Sir, we hope that we will get your guidance in future also. And again, once again, thank you, sir, to have a precious talking with you. Be with us and please stay tuned.
Maybe there are questions. Maybe there are.
Sir, we have make arrangement for question and answer in chat boxes. So
Okay.
we can have a discussion over there.
Okay.
Thank you once again. Thank you, sir. Now I request Professor Pratik Sonone, sir, Assistant Professor, Department of Physics from late Rajkamalji Bharti Arts Campus and Srimati Sushilabai Rajkamalji Bharti Science College, Army, to have an introduction of Dr. Abdul Hakim Deshmukh from China. Over to you, sir. Pratik Sonone, sir.
Hello. Am I audible?
Yes, sir. Yes, you are audible.
Good morning to all. Respected principal, sir, dignitaries on online platform, faculty members, participants, and students, a very good morning to you all. It's my proud privilege to introduce Dr. Abdul Hakim Deshmukh. He is currently working at the School of the Chemical Engineering and Light Industry, Gongwon University of Technology, China. He obtained his PhD degree in engineering from the Sejong University, South Korea. Beside the postdoctor from the Institute of Physics, Polish Academy of Science, Poland, his research interest includes the synthesis and characterization of the novel nanomicro size inorganic luminescence materials such as phosphors for the white LEDs and biodetection applications, particularly understanding the structural properties, relationship, and luminescence mechanism using the conventional characterization techniques to develop the efficient phosphors. As far as his publications are concerned, he has published more than 52 publications in the national and international report journals and has the citations of near about 500. His H index is 12 and his I-10 index is 17. So I would like to invite Dr. Abdul Hakim Deshmukh, sir, to give his speech. Over to you, Hakim, sir.
Thank you very much for the nice introduction. Am I audible?
Yes, sir.
Okay. Can you confirm that you can see my presentation slides?
Yes, sir.
It's visible.
Okay. So once again, thank you very much for just organizing these international webinars. I'm very happy to see that from Maharashtra, we are organizing many international seminars. This will help young researchers to get ideas about the research and they will grow. Basically, I am Dr. Abdul Hakim Deshmukh. I am basically from Akola district of Maharashtra, and I took my preliminary education from Akola only, and then I did PhD in South Korea. So I'm very glad that Maharashtra is now rigorously going forward in the research field also. Today, I will like to discuss some design and synthesis of novel luminescent material for photonics and other biological applications. So this is my Professor Hong Li Wang at a School of Chemical Engineering and Light Industry. So for my presentation, first I will go through introduction, why the phosphors are important constituent for different application. Then I will show some experimental details, how we can produce those phosphors. And then I will show my result, and finally I will conclude. So basically here I will introduce two basic application, white LEDs application and bio applications. So first, in order to understand the application, we have to understand the basic processes, physical processes. So we need to understand what is down conversion materials and what are up conversion materials. Basically, the photon conversion, these materials are photon conversion materials. So low energy photon can be converted into high energy materials, and high energy photons can be converted into low energy photons. So in this way, we have a good opportunity to use UV visible radiation to convert it to the visible radiation or near IR radiation, or in another way, we can also convert near IR radiation into the visible radiation. These two processes are different in mechanism. In down conversion phosphor, as you can see in the peak right side picture, the high energy photon can be absorbed by the material, and it lost some of the energy and then emit rest of the energy. So this is down conversion material is basically a one photon process where one photon is emitted and one photon is absorbed. But in upconversion material, here the material absorbs multi-photon by different processes, and then it goes to the higher level and then emit from there. So these are the multi-photon mechanism in upconversion processes. So these are the detailed processes. If it is very important to understand these processes. Some processes are only just one in this one activator can do excited start absorption, but for ETU and GSU, for other processes, we may require two atoms simultaneously, or also we can get the energy transfer from core shell structure also. So we can also prepare the nanoparticles and then coat it with some other inert layer, and then also we can get the energy transfer. So these are the basic energy transfer processes via which we can get the energy transfer. As far as the down conversion materials are concerned, they are widely used in light emitting material, light emitting diodes. So these materials, why they are very important? Because they are energy saving, they are highly efficient. Also, they have a very long lifetime. They do not produce a high amount of CO2 as in case of incandescent and CFL lights. We can see here, these are the statistics of the incandescent, CFL and LEDs. So LEDs can have very high efficiency, lifetime, as well as it doesn't produce CO2 emission. So also this is environmentally friendly because in LEDs we are not using mercury. In other incandescent light and fluorescent lights, we have to use mercury to excite the layer phosphor. So we can avoid using mercury, so it can be environmental friendly also. This is the basic history of the sources, different sources. Here we can see from 1920 to 2020, the other sources are not grown much, but in case of white LEDs and LEDs, they grown exponentially. And now it is expected that after 2020, almost more than 200 lamp per watt energy can be done by using LEDs. So for these LEDs, the application, there are many multi-application for this phosphor. These can be used in cell phones, in day-to-day life, also traffic signals, and these all kinds of applications we encounter in our day-to-day life. So they are very important, and to reduce the cost of these commodities, we need to find some phosphors which are cheaper, which has high efficiency, which can, as far as if we take the example of cell phones are previously very expensive, but now the cell phone prices are reducing, and because the technology used in that previous technology is now outdated and we are using some new technology using phosphorus, so it can stay for longer time, and its price is also decreasing day by day. So actually we have to create the light which is the natural is equal to the natural source. We have sunlight. Sunlight is a white light. It compares 7 different colors, but here in phosphorus, previous phosphors are only monochromatic color or mixing of 1 or 2, only 2 colors. So to produce white light, we have to mix the different color to get the white light. Here these are right sides are the different methods to get the white light. First, we can have only LEDs. We can use different blue, green and red LEDs, and if we mix the color, we can get white light. But here there are different drawbacks because of the lifespan of these LEDs, and these LEDs need more current to turn on the device and consume more electricity. That's why in 1960, YAG cerium phosphor was developed, and when it used with blue LED, only one phosphor can combine with blue LED to give white light. So these YAG cerium phosphor later in 2016 got the Nobel Prize for blue LED, for white LEDs. So after combining these data, still the parameters for these phosphors is not accurate. This phosphor is very efficient, but the color coordinates and the color rendering index of this YAG cerium phosphor is not up to the mark, because of this 600 to 700, this red emission is lacking in these LEDs, these type of LEDs. So later, people have replaced this YAG phosphors by 3 different color phosphors. When they use different 3 color phosphors, blue, green and red with UV chip, they found very high color rendering index as well as the other aspect of the LED is better. So also there is another one method we do not need UV chip also if we just combine the blue phosphor, green phosphor and red phosphor. But here nowadays only the combination of UV chip, UV or near UV chip with blue, green and red phosphor is at working condition because they are very less, they have low cost, easy fabrication and also they produce high efficiency LEDs. So due to these reasons we are nowadays the industry uses the UV near UV chip with tricolor phosphors. For these phosphor, still we are using the conventional phosphor like yak cerium phosphor or some conventional nitride phosphor for red emission. But these phosphors are not good for the environment as well as they are not easy to be synthesized because they need a very extreme condition, a very high temperature as well as we need to prepare them we cannot prepare them in air, so we need some special conditions to prepare them. So that's why developing new phosphors are the demand of the time, and we need some more phosphors to be developed so that we can use we can replace the conventional phosphors. So these are this is the way how to design the novel inorganic phosphorus. First we have to fix the structural model. Once we are fixed with the structural model that this model we have to work on, then we can change the chemical composition and we can optimize the chemical compositions and what is the suitable activator with that host. So after getting the structural and host activator relationship, we can synthesize them and characterize them and check their what is the efficiency or what is the parameter, if it is usable for the white LEDs or not. So for this nowadays LEDs, all the performance parameters are depend on the phosphor. What is the quality of phosphor? So we need to improve the quality of the phosphor, whether we can develop novel phosphors with high efficiency, or we can take the existing phosphors and we can just improve the efficiency by doing few modifications or few doping. So here are if we go to discover novel phosphors, then we have these main strategies where we can just imply that and we can select. So in that, first the single particle diagnosis is the technique where we can select trial and error method we can use, and we can select some different ions and combination of these ions we can just synthesize them, and after synthesizing we can just take out one crystal out of the full sample, and then we can scale up the synthesis using the crystal. But this is also very specialized task and need very high skills. So the second thing is solid state combinatorial chemistry. In this method, we can use the genetic algorithm by using computational methods, and we can prepare the phosphor libraries. Here, but if we build some algorithm by using hundreds of thousands of compounds, then it can give you the optimum composition for which the luminescence is possible. And then you can synthesize it in your lab, and you can check what it is performance, and based on this we can also select or discover the novel phosphors. The third one is the high throughput calculation. We already have the database of many materials. We can select the database, and by selecting the database, we can use the computerized algorithm. And these are computer algorithm is normally use band gap and debye temperature. These two types of various two types of conditions in machine learning. So if you put band gap and debye temperature, it will screen and it will give you the optimum host materials. And then you can plot the diagram like the shown in the figure, and you can select the optimum phosphorus and synthesize, and then discover the new phosphorus. So here previously I did the first to enhance. I have taken the existing phosphorus and try to enhance its efficiency. Here right side figure we can see while we doping the europium in this host BaL2Si2O8, we can increase the efficiency of this europium by just co-doping it with the monovalent ions like lithium, sodium, or potassium. So in my case, this is called as charge compensation, and due to the charge compensation, because here trivalent europium is occupying at divalent side, so it has some charge difference. To minimize this charge difference, we are putting one lithium monovalent ion to compensate the charge. We can see that the charges are compensated and luminescence intensity is enhanced. In other way, also we can use energy transfer. In energy transfer, when you dope some sensitizer along with the activator, it can transfer the energy from activator sensitizer to the activator. Here, europium, terbium has transferred its energy to europium, and by energy transfer from terbium to europium, 3 times the intensity, luminescence intensity has improved. So that was for the down conversion phosphor. For up conversion phosphor, mainly these are used in biological applications such as anti-counterfeiting. We can use it to check the validity of nodes, and many things we can do for authenticating. Also patterning, displaying, or detection. Nowadays in mobile fingerprint detection or some like this application, we need some nanophosphors. For bioimaging also we can use in nano composites. So why these upconversion materials are needed? So basically there are two advantages of near IR excitation source, because upconversion phosphor is the phosphorus which convert low energy photon into high energy photon by absorbing multi-photon. So here near IR we can use two lasers. One is 980 and 808. These are the two lasers, are already established lasers for upconversion phosphor. Here you can see that the 808 nanometer laser can have a high penetration, tissue penetration, because it can go up to 5 millimeter also we can see inside the tissue. Also, it doesn't have any autofluorescence, because these are near IR radiations are very weak, so it cannot harm the tissues of the probe, and that's why there is no tissue autofluorescence. Otherwise, if you use UV excitation source, there will be a fluorescence from these tissues. So because of this, there is no tissue damage also, because of the low energy of these near IR excitation light sources. So if we use these upconversion materials and dope some rare earth ions in that, we can use the property of rare earth ion dopes in upconversion material. So these narrow emission bands is the first important characteristics of the rare earth ions. Also, long lifetime and no toxicity are the other advantages. So another we have here focused on exploring the novel phosphors. So in my this today's topic, I have just focused on these both the luminescence UV as well as DC emission. If we have these both emission in the single host, then it will be very good, because sometimes if we study the up conversion only and some host we are studying down conversion, but if we study both and we have the both luminescence in the single host, that will be more appropriate, and only the single phosphor can be used for multi application as well. So to develop near IR emission and also to use 808 nanometer excitable upconversion materials. Normally in today's science, people use ND as a dopant because ND can absorb 808 nanometer radiation efficiently, and then it transfers the energy to the YB, and then we have to dope ER-ND-YB, 3 dopant inside one crystal. So that is also troublesome. Also, if we use this one, we can see here, if we use 980 excitation laser, it in bioimaging, it can produce a hotspot. And due to this hotspot, the living cell of the probe can be damaged. So to remove this kind of disadvantage, one can use 808 nanometer excitation. And here it is proof that the 808 nanometer is very cool and there is no hot spot. So it can prevent from dying. So because of these advantages, I have just focused on the single host material with dual emitting luminescence. So in synthesis method, we use very simple and frequently used methods like solid state method and hydrothermal methods. So these are not very complicated method, and the procedures are already available in the literatures. So I will not go through in the detail of this. So I will start with my result and discussion. Here I have used different phosphor materials and with different doping. These down conversion phosphors and up conversion phosphors are different. You can see here, if we dope europium, cerium or chromium, we can get down conversion emission. And if we dope ER and YB, then we can get the up conversion emissions. So this is my first results about BASR Al2SiO7. In here, we doped europium and dysprosium co-activated samples. Here we can see that the band gap of the sample is around 2.6 to 3, and it is changing, increasing with increase in the dopant concentrations. Also, if we see the PLs of both, this broadband PL is from the europium. This black curve and red curve is from the europium samples. We can see that the emission of the europium is covered by the excitation of the dy, the C curve. Here there is a big overlap. So this overlap can show that the energy transfer can be possible. So when we code up the sample, we can see that the emission intensity of the europium, this is red curve at the right side, is enhanced, highly enhanced. It is up to 3 times with that of the only europium dope samples. So when we took this thermoluminescence, thermoluminescence shows that the defect in the europium dope phosphorus has been decreased by co-doping the dy. Also, the lifetime has been increased. So this is the table showing the lifetime values and the CIE coordinates. So another phosphor is the garnet-based phosphor, where Y2LACA Ga3ZrO12. In this is interesting garnet host, because this is the I have just substituted the YAG phosphor because YAG cerium phosphor is not good. So we need to improve the red quality of the phosphor from this. So to improve the red quality, we can also do it by changing the host. So here, instead of Y3Al5012, I have used Y2LACA Ga3ZrO12. These garnet phosphors are typically has 3 different sites: dodecahedral sites, octahedral sites, and tetrahedral sites. So we have the opportunity to dope the rare earth ion at different sites. Here Y2LACA is at dodecahedral site. This is the biggest site, and Ga2 is the octahedral site. This is the mid range, and this zirconia is at tetrahedral site, and this is the least ionic radii of the site. So we can dope different ions at different sites, and we can get different luminescence. Here, here we can see the XRD patterns are all single phase phosphor, and previously in my PhD work, I have reported its ritual refinement and crystal structure data already in one paper. So I have not done any crystallography of this phosphor, and directly we are just discussing the optical and luminescence of these phosphor. FTIR also proved the successful synthesis of this phosphor, and we can see the lifetime is also comparatively longer than the existing samples. Also, the lifetime of the 0.02 cerium dope sample, lifetime of 0.08. So with increasing cerium, lifetime is also increasing. These are the PL typical cerium excitation and emission spectra. We can see here only single phosphor can emit from 450 to 750. So this region compares blue, green, and red. So here we can see from 600 to 750. This all region is red, and this is much covered by the phosphor. So when we code up with cerium, we can see that cerium can also transfer energy to the manganese. Here there are different sites in the host also, but in here it is interesting to see the first site. This is the cerium luminescence is decreasing, and this is the second from 600 to 800. We can see not much decrease. So this is due to the manganese occupied at octahedral site. So due to the change decrease in the cerium, we expect the energy transfer from cerium to manganese. When we change the excitation to 260, we can here clearly see that the same sample in here, we cannot at 428. This is the cerium excitation wavelength. At cerium excitation wavelength, we cannot see any peak from manganese. But if we change from 428 to 260, the energy is high, and that's why we have the peak from 650 to 800. We have a broad manganese peak also included in the phosphorus. So this will increase the red emission intensity in the phosphorus. Also will change its color tunability as well as the performance of the phosphorus. So if we dope CR, the story is little bit different. If we dope chromium, chromium can go to the dodecahedral site, and that dodecahedral site, we can see that this is also the single phase. There is no any other phase. Here, cerium has the very good absorption at blue region. So here it can absorb blue LED chip radiation very efficiently. And after absorbing this blue LED, this can emit red emission. So we can broad red emission from 700 to 800. We can use such type of phosphorus, mix it with the YAG, because YAG don't have enough red emission. We can use this chromium dope phosphorus with that, and we can get very efficient LEDs. So this is the same, even then the lifetime of the chromium dope sample is even more than the cerium dope samples and cerium Mn dope samples. Now let's begin with the upconversion phosphorus. In upconversion phosphorus, I have selected lithium aluminum silicate, LiL Si2O6. This with doping ER and YB. Here, because ER absorption is very less and they are very weak absorbing ions. So we have to co-dope it with YB to enhance the absorption of ER. So in this phosphor also, when I synthesize it by solid state method, we can see that the single phase phosphorus has been synthesized, and there is no any impurity. FTIR also clears the also support the XRD results, and there is no any impurity peak arises. These are the peak assignment. We can see that ALO4 and ALO6, which is the characteristics of LiL Si2O6, is present in the FTIR spectra. So later we just use UV visible NIR spectroscopy to check the near IR absorption of the material. When we check the absorption material, there are several peaks have been observed. So these are the assigned already to the transitions of ER. Here the main thing which we can see that the absorption peak near 980 is due to 4I 15 by 2 to 4I 11 by 2. This peak is having two contributions. It can come from the ER as well as it can also come from YB, because YB is also having the absorption at this peak. Also, when we co-dope with ER, we can see that this 980 peak has enhanced. That means energy transfer from ER to YB is increasing with increasing in YB. So later we check the band gaps of these materials. These are also consistent with the reported data. The reported data for LiL Si2O6 is 4 electron volt, and we can see here that the band gap is nearly 4. and it is not increasing much with increasing in the activator. So it is basically in between 3.5 to 4. So this is the excitation spectra. Excitation spectra also shows the different ER peaks with one broad peaks. Broad peak may be from the host absorption, and these are assigned as in shown in figure. So here also by excitation we can see that we can excite this sample via different wavelengths. So different lasers we can use to excite this sample. We have used here the 380 nanometer UV excitation and observe 980 nanometer peak. Here you can see that with increase in the YB, the 980 nanometer peak, which is from 4I11/2 to 4I15/2, this transition, it is increasing and there is no concentration quenching. That means that when it is depending on the YB concentration. As the YB concentration is increasing, this is continuously increasing. So there is a overlap of this transition with the YB transitions, and due to that the intensity of this transition is increasing. Also, when we observe the near IR peak, we can see at 318 nanometer excitation also we can find the near IR 1535 nanometer broad peak. So these can be used for the biodetection and in different bio applications. So here we have we have analyzed this data, and we found that the peak at 1335 is arises due to the cross relaxation process, because the excitation wavelength is 380, and it is not due to the quantum cutting. That in quantum cutting we absorb one photon and we can get 2 photons. So this is not quantum cutting. Also, we have changed the excitation source from UV to laser, 980 nanometer laser. Here also the same emission peaks can be observed. Also, these peaks increase with increase in YB, so there is also a energy transfer happening in this sample. So we calculated the difference between the ions by using this equation. The critical concentration of this YB and ER in this material is found to be 25 angstrom. So if the distance between the activator and sensitizer is more than 5 angstrom, then these mechanism takes place due to multipolar interaction and not due to the exchange interactions. So also the same sample, if we excite by 980 laser, we can also observe some emission peaks at visible region. Here we can see clearly that we have green emission peaks as well as red emission peaks, and upconversion emission is at visible region is also increasing with increase in YB content. So that is also a good for the increasing the efficiency of the phosphorus. These are some of the parameters which are used in application like this FIR. FIR is the ratio of the emission peaks. Because 523 nanometer is sensitive to temperature, so these, if we calculate G1 by G2, means 523 nanometer peak divided by 543 nanometer green peak, we can get the value which is approximately same as and used in thermometry. So these values are decreasing. So we can see that the ratio between the peaks are changing. So this is also important if ratio between the emission peaks is changing, we can also use them to detect the temperature. So in thermometry also this phosphor can be used. So that was about the 980 nanometer laser, but 980 nanometer lasers are harmful for the living cells. So we have to get the phosphorus with 808 nanometer. So this sample, you can see that these samples are also can be excited by 808 nanometer laser. And the purity, because of 980 nanometer, we have a higher green peaks. So the ratio between the red and green is lower in 980. But if we use 808 nanometer, not only the cell damage can be restricted, but also we can get the pure red light emissions. So also when we code up it with YB, we can see that green emission is almost quenched. So there is no green emission. So the purity of the phosphorus is almost high. In this table, we can see the purity of the phosphorus of ER phosphorus is increased from 42 to up to 91%. So the YB code of phosphor has higher color purity. These are the color coordinates which lies in the orange region. So this is basically the mechanism. If we want to find the two dual emission in the single host, we have to have down conversion as well as up conversion emission simultaneously happening in the same host. So we can use ER and YB codec, and these are the different mechanisms by which the luminescence can take place. So this is the simple diagram showing the mechanism of these phosphors. Simultaneously, when I use this material LiAl SiO4, the similar results can be obtained by using different silicates. So here different silicates I have prepared. Here interestingly, we can change the temperature and we can control the phase at 1000. This phosphorus has different phase than the 1300. So depending on the phase change also, we can get different emissions and different efficiencies. These are the doped and co-doped samples. Here we can see that still this is at 1300. The crystal structure is low Carnegite type sticker. So this crystal structure hasn't changed with ER and ER-YB CODO sample. Excitation of spectra also shows that we can also use it for 380 nanometer excitation as well as 520 or 650 also. Depending on the different excitation, we can get different results. Also, by changing the temperature, we can also enhance the absorption and resulting, we can get the enhanced luminescence intensity. So these are, I will go quickly from these results because these are similar to these results. These are the green and green and red emissions. Here we can see that at 1000 the emission is very weak and the difference between the red and green emissions are the ratio is very low. But as we increase the temperature, the green emission is suppressed at 1200. But when we increase it to 1300, so depending upon the crystal structure, here we are getting higher green emission than the blue. So here we can tune the temperature to get whatever resultant luminescence we need. This is also similar type here. By using 808 nanometer laser, we can get the pure red emissions and green emission can be quenched. Even even the temperature also doesn't affect it. So this is at 1300. We have the difference between 980 and 808 nanometer laser. Here we can see 550 nanometer emission is higher and 650 emission is low. But at 808 nanometer, it's quite opposite to what we obtain at 980. So when we code of ER and YB and check its near IR emission is also increasing with the YB doping, and we have very strong emission in the near IR. So these are also near IR emitting phosphors. Also, this can be applied not only to aluminosilicate but for also the garnet phosphorus. Here with garnet phosphor, if we have ER, we can also get the very higher green emitting phosphor. So previously, by using aluminosilicate, we get higher red emitting phosphor, but if we change to garnet, we can get high green emitting phosphorus, and we can also get the near IR emissions at 380 nanometer. So we can see here also the lifetime is very long in few milliseconds. So this is also very good for the biological applications. So in conclusion, I presented here different down conversion and up conversion phosphorus, which are synthesis by different processes for different applications. Mainly, we focus on the dual mode emission in single host phosphorus and optimizing its concentration and luminescence via different strategies. So with this conclusion, I like to thank the organizing committee for inviting me, and that's it for today's presentation. Thank you very much. Hello.
Thank you very much, sir. Your explanation process over LED certainly was very descriptive. LEDs are the better options in every aspect over the traditional ones. And the topic of illuminescence explained by you was very interesting. Again, thank you very much, sir. Be with us and stay tuned.
Thank you.
Moving forward, I would like to request Dr. Jitendra Consalve, Assistant Professor, Department of Physics from Dr. Rajkamalji Bharati, Arts Commerce, and Srimati Sushilabai Rajkamalji Bharati, Science College, Arni, to have an introduction of Dr. G.G. Mule from Amravati. Over to you, sir.
Thank you, Dr. Deshmukh, sir. Good afternoon, all. I am Dr. Jitendra. With great pleasure, on behalf of our college, warmly welcome you all for this session. It is my privilege to introduce to today's speaker, Dr. G.G. Mule. Sir, it's our fortune to have you as a resource person. Dr. G.G. Mule is working as assistant professor and head at Department of Physics, also coordinator, postgraduate teaching department of Dr. Babasaheb Ambedkar Thoughts, also coordinator of Buddhist Studies Center, coordinator Dr. Ambedkar Studies Center, Sant Gadge Baba, Amravati University, Amravati. He has teaching experience of more than 18 years and 25 years of research experience. He has around 134 research papers in reputed peer-reviewed international journals, having more than 2,000 citations. He has 5 books to his credit. Also, he has completed more than 10 research projects owing to approximate cost of rupees 2 crore. He had guided 8 students to their doctoral studies, and currently 6 students are working for their doctoral studies. Sir had received many awards and honors from different institutes. Among them, I would like to mention here some. Sir has received Best Service Award by university teachers by Sant Gadge Baba Amravati University Amravati for year 2017-18. Also, excellent article award in 2018 by Journal of Material Science and Technology. He had organized many national and international conferences and various programs. With this short introduction, I would like to invite Dr. G.G. Mule to share his thought. Over to you, sir.
The speaker is not.
Sir, unmute yourself.
Unmute yourself.
So first of all, I thank organizer of this international webinar on recent trends in physical and mathematical sciences for giving me chance to present the work of my research group. Very good afternoon to all participants, organizing committee members and delegates. So I will talk on the nonlinear optical properties of nanostructures. So in this my talk, I will just firstly give you the introduction of nonlinear optical effects, and then whatever our work is based on is this thermal lensing effect. So I will discuss a little bit on that one, and the technique used to study the nonlinear optical properties, and lastly I will present a few results of our group. So all of us, the optical properties are governed by the polarization, which depends on the electric field of incident radiations. So in linear optics, the polarization is directly proportional to electric field, and in optics, these properties such as refractive index, absorption coefficients, they don't depend on the intensity; they are linearly dependent. They are independent of light intensity. And in optics, the principle of superposition it holds. In linear optics, the frequency of light doesn't change. So, for example, in reflection, transmission, refraction. So frequency of the light it will remain same. It will not change. And in linear optics, if two beams are passing through the medium, they are not interacting with each other. Means one beam cannot. Yes, pardon.
Sir, please off your speaker. So I think here we get some noise problem.
Is it?
If it is possible to have headphones, then it will be better, I think.
I will use it.
Yes, sir.
So I will.
Sir, just now it will better, sir. Now it is better.
Is it now okay?
Yes, sir. Okay, sir.
Is it okay now?
Yes, sir. No problem.
Okay. So in linear optics, if you see, the one beam cannot interact, one beam cannot modify another beam. So there is no effect of one beam on the another one. So And again, in linear optics, we are dealing with the low intensity radiations. We can produce electric field in the medium. It is of the order of 10⁻³ volt per centimeter. And if you see the interatomic interaction field, it is of the order of 10⁻⁷ to 10⁻10 volt per centimeter. It is very large as compared to the electric field developed by the light, which is inciding on the medium. So it is whatever the disturbance or it is created by the electric field of incident light, it is linearly related with the intensity of the radiations, intensity of the light. But in nonlinear optics, if we are dealing with the high intensity of radiations, so in that nonlinear optics, as your medium is interacting with laser radiations, so in that case intensity is very less, and so that the polarization will not remain linearly related with electric field. So the polarization, it will be proportional to the electric field and higher power terms of electric field also. Okay, so because of that, the refractive index in the medium, it becomes intensity dependent, so that the velocity, speed of the light in the medium, it changes. In this one, the principle of superposition, it will not remain valid. And in this case, the frequency of the light may change. It is changes as it passes through the medium. For example, you can convert IR into the visible radiation or ultraviolet radiation. In this way, the two beams are passing through the medium, so it will interact. So one beam can be modified by the other. So here in the nonlinear medium, light interacts with the light via the medium. And as we are dealing with the high intensity beams, laser beams, so the electric field developed by the laser beam in the medium, it is of the order of 10⁵ to 10⁹ volt per centimeter, which is comparable to the interatomic field of the order of 10⁻⁷ to 10⁻⁴ volt per centimeter. So there is a non-linear disturbance is developed in the medium. So that's why it is giving you the non-linear optical properties. So these non-linear optical properties are really intensity dependent, and they are visible only with the high intensity radiations, laser radiations, so that whatever the non-linear optical properties have investigated or observed, so they are observed, all have been observed after the invention of lasers in the year 1960. So first non-linear optical effect, that is second harmonic generation, was investigated by the Franken and his co-worker in the year 1961. So they have used Ruby laser. It is the first laser invented. So that Ruby laser, the light was focused by focusing lens, and it was allowed to incident on the quartz crystal. And then prism is used for the dispersion of the radiations, and then they have recorded the fundamental wavelength, and then half of that fundamental wavelength, that is second harmonic signal. So this is the first experimental observation of second harmonic generation, and after that so many nonlinear optical effects have been observed. So if you consider the polarization P, it is depending on the electric field. E is a high power E square, E cube and E4. Okay, so if you consider the electric field associated with radiations or light, it is proportional to cos of omega t, and if you put that one in the polarization and have the mathematical calculation, so we shall get the terms in polarization. It is a P0 plus P1 cos of omega t plus P2 cos of 2 omega t plus P3 cos of 3 omega t, so like that. Okay, so P0 you are getting DC terms. So as we are irradiating the nonlinear optical medium with light of frequency omega, but in that case also we are getting the polarization, DC polarization, that is the potential is developed across the crystal. Again, at the output we are getting the radiations with the same frequency omega. We are getting radiations of frequency 2 omega, it is the second harmonic term. We are getting the radiations of frequency 3 omega. So like that. So at the output we are getting so many radiations. Okay. So there are we can have the second order, third order, fourth order nonlinear optical properties. But the higher order non-optical effects, because of the electrical susceptibility is very small, so that's why we cannot observe. But the most interesting nonlinear optical effects are second order and third order phenomena. So in second order we can have this frequency conversion. So it is some frequency generation, difference frequency generation, second harmonic generation, parametric amplification, parametric oscillations. So these are the optical Pockels effect. So these are the second order phenomena. Third order phenomena includes third harmonic generation, self-phase modulation, self-focusing and defocusing. It is depending on nonlinear refraction. Four-wave mixing, stimulated Brillouin scattering, stimulated Raman scattering, which leads to the optical soliton, optical bistability in the materials. Okay, so so these are the different terms in polarization and corresponding nonlinear optical phenomena, and these are the years of their discovery. So in our research work, we concentrate on the third order nonlinear effects, and in that one we are if you consider the term corresponding to the third order nonlinearity in polarization, so which is this one, P 3 of t is equals to epsilon 0 chi 3 E of t cube. Okay. So if you consider our electric field associated with light, it is this one, E cos of omega t, oscillating with frequency omega. So if you put in this polarization term, so at the place of E of this cube, so having mathematical calculation, we can have these two terms. So one term, it has a cos of 3 omega t, means it is oscillating with frequency 3 omega and frequency omega. So this first term is corresponding to the third harmonic generation, and second one is we are getting the same frequency at the output, but it is modified with this third order nonlinear optical susceptibility, and it is said to be a nonlinear contribution to it. This is the this corresponds to the nonlinear contribution to the refractive index explained by the frequency omega, and we are interested with this the nonlinear optical refraction refractive index of the nonlinear medium, nonlinear optical medium. Okay, so as our light has a high intensity and it is passed through the medium, nonlinear refractive medium. So the nonlinear refractive index, it will be proportional to the intensity. As intensity varies, nonlinear refractive index is varied. So this can be written as n of I is equals to n0 plus n2r. N of I is the intensity dependent refractive index, total refractive index. N0 is the refractive index, intensity independent refractive index, plus N2, it is a nonlinear refractive index, and I is intensity. Okay, so this nonlinear refractive index gives us so many interesting phenomena, and they have so many applications in different technologically important fields. So, and this N2 is given by this one. Okay, so this N2 may be positive or it may be negative. So refractive index, it may be positive or it may be negative. So that total refractive index may increase or decrease with intensity. So there will be, if it is increasing, then it leads to the self-focusing phenomena. If it is decreasing with intensity, then it leads to be self-focusing phenomena. So for laser beam, it is a Gaussian beam and it is passed through the medium. So intensity at the center, it will be large and it will be increases radially. It will decreases radially. So it is forming a Gaussian intensity profile inside the material, so that the refractive index change as the refractive index of the medium it is changing, and with the intensity, so there will be a change in refractive index in the medium, and there will be a Gaussian profile inside the medium. So which leads to the either self-focusing or self-defocusing, depending on the sign of second order nonlinear refractive index. Optical Kerr effect. So in this case, the refractive index is proportional to the square of the electric field of associated with the radiations. So this effect is used as as optical switches in optical communications and in lasers. Another one is a non-local effect. It is because of as laser is passed through the medium, and because of that intensity, the medium is heating, and that medium, because of that heating, there is a variation in the intensity of the laser, and because of that, there is a gradient in the field, and so because of that, there is a gradient in the density in the material, and because of that, the polarization inside the material, it is different one, and so that there will be a change in refractive index in the medium. Another one which results into the change in refractive index is because of the saturation, so which includes different kinds of processes, reverse saturable absorption, two photon or multi-photon absorptions. Okay, so this effects leads to the change in the refractive index of the material. So this has so many applications in nonlinear spectroscopy, optical switching, optical logic gates, optical communications, optical limiting, laser mode locking, waveguide switches, modulators, etc. So in our work, we are just finding the which types of nonlinear refractive index is that, whether it is positive or negative, which types of material is this one, whether it is self-focusing and or self-defocusing. Then we are deriving, we are estimating the nonlinear, third order nonlinear electrical susceptibility, and then we are studying the optical limiting properties of the material. So these optical limiters are interested, it is required when we deal with the high intensity laser radiations. So with high intensity laser radiations, we are using very costly sensors or other optical devices. Sometimes what happens, the laser intensity increases and goes above the required or the intensity with which your sensors or your other elements withstand. So because of that high intensity, your sensors or other elements may damage. So to protect those elements, those sensors or other optical elements, we require optical limiters so that they will allow to pass particular the laser radiations up to particular intensity, and if intensity goes above that allowed energy intensity level, it will not pass that radiation through that one, so that we can protect our valuable sensors, other detecting elements, optical elements, and so on. This can be achieved if your material is self-defocusing. So as the intensity increases, it defocuses the radiation so that the output intensity, the light intensity density will be less, so that the material should have a self-defocusing property, that is refractive index should be negative. Again, other phenomena also contribute to this optical limiting properties, that is nonlinear optical scattering and this saturable absorptions. The nonlinear absorption includes excited state absorption, saturable absorption, two photon absorption, reverse saturable absorption, free carrier absorption, two photon assisted excited state absorption. In physical processes, the nonlinear change in refractive index. It is because of these processes, that is electronic polarization, molecular orientational polarization, electrostriction, saturable absorption, thermal effect, and photorefractive effect. And if you see the contribution to the refractive index, nonlinear refractive index by this mechanism, electronic polarization has contribution around 10 raised to power minus 16 of the order of 10 raised to power minus 16 centimeters square per watt. The Chi3 value, the third order nonlinear electrical susceptibility value is of the order of 10 raised to power minus 14. And response times, if you see, it is 10 raised to power minus 15 seconds. It is very small. It is 10 raised to power minus 15 seconds. Molecular orientational this polarization, it has a contribution to the nonlinear refractive index N2, it is of the order of 10 raised to power minus 14, and response time is 10 raised to power minus 12 seconds. Electrostriction, it is 10 raised to power 14, it is contribution to the N2, and response time is 10 raised to power minus 9. But if you talk about the thermal effect, thermal effects, it is a contribution is 10 raised to power minus 6 of the order of 10 raised to power minus 6 to the nonlinear refractive index N2, and response time is only 10 raised to power minus 3 seconds. It is a millisecond. Okay, so if you deal with the continuous wave lasers, so that the contribution from this electronic polarization, molecular orientation, electrostriction, and the saturable atomic absorption, it is very less as compared to the thermal effects. And again, response time for this one is very large. So if we deal with the continuous wave laser, so the thermal effect contribute more, so that whatever the nonlinear refractive index and nonlinear diffraction we are getting, it is mostly because of the thermal effects. So in our experiments, we are dealing with, so we have studied the nonlinear refractive index of the material using simple HENE laser, 10 milliwatt HENE laser, and certainly it is showing the whatever the change in nonlinear refractive index we are getting, it is because of the thermal effects. So in the study of nonlinear refractive index of the material prepared, we have used a very simple technique, but it is a very accurate technique, and it is a Z-scan technique. It is designed by the Bhai and his co-workers. So in this experimental setup, this laser beams is firstly splitted, and one part is sent to the reference detector. Another part is passed through the focusing length, and it is passed through the sample is placed here. Another beam splitter is here to split the beam into two parts. One goes through the aperture to the detector, and another directly to the another detector. So here, if this radiation which is passed through the small aperture, very small portion, around 0.5%, it is 50% or less than that one is passed through this aperture to the detector, then that particular technique is said to be a closed aperture Z-scan technique, and this whole part, it is passed to the detector. Sometimes we can put here a focusing lens so that radiations can be focused to the signal can be focused to the detector. So in this experiment, we can use we can do this experiment. This is open aperture Z-scan technique, and this is closed aperture Z-scan technique. We can do simultaneously if you put a beam splitter, but we require two detectors here. If you don't have the detector, so you can perform this experiment 2 times to have the results. So here the sample is moved along this direction of laser. So it is the direction of incidence of the laser. It is assumed as Z direction. That's why this is to be a Z-scan technique. And the sample is translated about this focal point of this focusing lens. So at the focal point, you will have the maximum intensity, and above from this on this other side, the intensity of the laser will change. It will decrease on either side. So as the sample is translated at the focal point, you will get this type of this intensity. But if you translate about this focal point, intensity at this closed aperture detector, it varies. So you may get this type of intensity variation. Firstly, this you may get the value in the intensity, and then it is increases and you will get the peak. So if you move, if it is on this left hand side, so you may get value firstly, and as it moves to the right of focal point, then you will get the peak. Okay, so firstly the dip and then peak, or you may get firstly the peak and then dip. You are getting firstly valley and then peak. So the variation, the refractive index is -1. So the refractive index is negative. So this is the results. This kind of results we can get in case of closed aperture gel scan technique. So the intensity transmittance is assumed 1 when our sample is at a focal point, and as you move about this one, so if your material is self-focusing, it is self-focusing, then we shall get firstly the value here, N2 is greater than 0. So N2 is greater than 0. When it is on the right hand side of your focal point, you will get peak, and when it is on the left hand side, you will get dip. So in this case, N2 is greater than 0. It is a self-focusing. Here it's firstly when N2 is less than 0, then you will get the peak and then valley. In open aperture means total output ray signal is given to the it is going to the detector, then you may get peak at the focal point, or you may get the value at the focal point, or you may get nothing. So if you are getting a peak, then certainly there is a excited state absorption to photon absorption or multi-photon absorption process is occurring, because it is absorption, it is intensity dependent absorption, and it is absorption is more when intensity is more. So it may be because of excited state absorption or or multi-photon absorption. When you are getting a value, then certainly it is a saturable absorption. So from this one we can talk about which types of absorption processes is going on. In our study, we have synthesized nanoparticles by a simple chemical route method and chemical precipitation method, and we have studied the envelope properties. So as we know, the nanostructure materials offer great advantage over the bulk material, as it is because of the surface to volume ratio and quantum size effect. Semiconducting quantum dots also show significant optical, non-optical properties because of quantum size effect and excitonic oscillator strength. And there are several mechanisms reported here in the nanoparticles that gives you the nonlinear absorptions, including the two proton absorption, reverse saturable absorption, transient absorption, free carrier absorption, and nonlinear scattering. But the nanoparticles, if you are using this nanoparticle as an optical limiter, so we have to just place the layer of this nanoparticle on the either on your element, optical element, or at the front side of your sensor. So it is not possible to coat the nanoparticle directly. It will be easy if you blend, if you prepare the nanocomposite with certain polymer matrix, then it will be easy to apply thin film on the your elements. Okay, so that we have just prepared a nanocomposite with different polymers, and then we have studied the nonlinear optical properties. So in our case, we have used HNA laser, a 10 milliwatt HNA laser, and as it is a continuous wave laser, so certainly thermal effect, it was a dominant one. And because this thermal effect, as a laser is passed through the medium, it hits the medium. That's why that it is producing that acoustic disturbance, and which propagate radially, and that's why there is a variation in the density, and so there is a change in refractive index. Okay, so we shall now we have synthesized nanoparticles by chemical precipitation method. Then we have used surface modifier as amino acids. L-arginine, we have tried L-arginine, L-alanine, L-valine, and other amino acids, but we found this L-arginine is most effective. We have we have just mixed this whatever the nanoparticles we have prepared in the polyvinyl alcohol, and then we have prepared in films by using spin coating technique, and then we have studied the nonlinear optical properties. So first of all, we have studied the ZNO nanoparticles doped with strontium and copper, and then we have prepared the nanocomposite thin films with PVA. So as we know, this ZNO is a wide band gap semiconducting material and has a band gap around 3.3 electron volt. And a nanostructure ZNO with increasing energy band gap shows strong nonlinear second order and third order susceptibility. So that's why we have used this one, and also it is found that it is useful for as a optical in a optical limiting and switching application. So that's why we have selected that one, and we have doped this it with strontium and copper. And these nanoparticles were stabilized with L-arginine, and then nanocomposites are formed with PVA polymer. So we have studied the third order nonlinear optical properties, nonlinear electrical susceptibility, and refractive index. And we also studied optical limiting properties with 808 nanometer continuous wave diode laser. Okay, so here different samples we have prepared. ZNO with one weight 1, 2, and 4 weight percent strontium, and then copper, and then nanocomposite thin films. So these are the thin thicknesses which we have prepared. XRD, we have taken the X-ray diffraction patterns to confirm the phases of whatever prepared nanoparticles. We intend to find out the particle size. Elemental analysis we have also done, FTIR, and then UV visible spectroscopy. So this is the close aperture Z-scan pattern of the first one is the strontium doped ZNO PVA nanocomposite. So from this graph you will see, firstly it is this is the 0 corresponds to the focal point of that lens. So it is firstly we are getting peak and then valley. So certainly from this one we can say that the nonlinear refractive index one is -1. Means our material is defocusing type of material. So certainly it can be used as optical limiters. So from this graph we can talk about the sign of refractive index. So these are the normalized graphs. This is for pure ZNO and PVA. This is 1 weight percent ZNO and strontium. This is for 2 weight percent ZNO and strontium, 3 weight percent. This is 5 weight percent ZNO and strontium. Okay, so from this one we have derived the values of refractive index. So this is the refractive index of pure ZNO in PVA. It is 2.33 into 10 raised to power -4 centimeters square per watt. This is the refractive index, this electrical susceptibility, third order nonlinear electrical susceptibility. and from this one we have derived these values. So interestingly, we can see the values are increasing with increasing concentration of strontium in the medium. This is the head scan patterns of Cu doped ZNO. Again, we are getting the firstly in this graph, we are getting first peak and then valley. So our material is defocusing type. It is has a negative or nonlinear refractive index. This is the open aperture Z scan. So in this case, at the focal point, we are getting valley. We are getting valley. So certainly it is because of saturable absorption. So saturable absorption process is there. So there is a very strong absorption in this one. So these are the values, N2 values estimated for this copper dope ZNO nanoparticles. Then this chi effective, that is nonlinear refractive, nonlinear. This is nonlinear refractive index, and this is third order nonlinear electrical susceptibility, which we have derived. We have compared these our results with the earlier reported results. So this is SR dopes ZNO PVA thin films. So we found the refractive index is 6.507 into 10⁻⁴ centimeter per watt. And if you compare with other, so this is Yemen 58% dope. It is reported earlier by other peoples. So it is 3.23. Other have reported this one. In this case, they have they found a larger value for Ni nanoparticles in ethanol. This FCF dies, it is less as compared to our one. Okay, so whatever the result we got, it is good as compared to other results, few results. We have studied optical limiting properties of this one. Optical limiting property means it should allow the radiation up to particular intensity to pass through that material, and high intensity radiation must be suppressed. So here in the input, we have given, we have used 808 nanometer diode laser, and we have varied the input power, and we have measured the output power. So firstly, we have seen the output power increases linearly with the input power, but as certain intensity reach, it is around 17 milliwatt at the input. The output intensity is it is becoming constant. It is becoming constant. So this is the black one. It is curve is for pure ZNO nanoparticles with the PVA nanocomposite. So it is showing it allowing somewhat higher intensity. As we are using a dopant, strontium dopant, this allowed intensity goes on decreasing. So for this 5% strontium doped ZNO nanoparticles, it allows less intensity, so that we can vary the dopant concentration. So we can vary the by varying dopant concentration, we can vary the output intensity. So certainly these materials can be used as optical limiter, optical limiting materials to protect our devices or sensors. This is another figure. It is also showing the optical limiting study of copper dope ZNO nanoparticles. In this case also we are getting the same results. So the as concentration of the copper it is increasing, it is allowing less intensity to pass through that film. So this material can also be used as optical limiting materials. In another study, we have we have studied copper oxide nanoparticles doped with CD, cadmium, and strontium, and nanocomposites formed with polyvinyl alcohol. And again, we have studied its different properties. We have prepared these samples. Then these are the film thicknesses we have developed. and we have used this other techniques to confirm the structure, phase, then particle, we have measured the particle size using TEM, XRD, elemental analysis to confirm the presence of elements, visible study to find out the band gap. And this is the nonlinear optical, this is a close aperture Z-scan pattern of SR CuO PVA nanocomposite thin films. In this also, when you can see, there is a first peak and then there is a valley. So certainly our material is self refocusing material. It has negative refractive index, negative nonlinear refractive index. And from the separation between this peak, we can find out this nonlinear refractive index, then nonlinear optical susceptibility. This is the cell. This is open aperture Z-scan, and in this case there is a decrease in the intensity when our sample is at the focus. So there is a multiphoton or reversible saturable absorption. So here we are getting a value at the focal point. So in this case, as intensity increases, absorption in the medium is increases. So certainly the material can be used as an optical limiter. Okay, so this is the Z-scan study of Z-scan patterns of CD-doped CuO PVA nanocomposite thin films. In this case also, these materials are showing firstly the peak and then valley. So these materials also have negative nonlinear refractive index, and these materials are self-refocusing type of materials. Open aperture Z-scan pattern shows there is a peak at there is a valley at the focal point, means a lot of radiations are absorbed. So if these are showing there is a absorption process are surely the multiphoton absorption or reverse saturable absorption. We have calculated this nonlinear refractive index for this material, then nonlinear absorption coefficient, then electrical susceptibility. Okay, so these are the values. Again, one can notice that there is an increase in the values of refractive index, nonlinear refractive index, as the concentration of this strontium dopant is increasing in the material. We have also studied the optical limiting properties. So this black curve, it is for the pure PVA film. So it is not showing any optical limiting. So PVA thin film is not showing any optical limiting. The output intensity is proportional to the input intensity. So it is the output intensity continuously increases linearly with input intensity. So PVA is not showing any optical limiting. So whatever the optical limiting properties we are getting, the effect we are getting, it is because of this copper oxide nanoparticles and then its dopant. So here also we can see the same trend. As the concentration of dopant increases, the intensity, allowed intensity at the output, it is decreases. So in this case also one can tune the whatever the intensity we require at the output with the concentration of the strontium in the medium, in the material. Okay, this is the optical limiting study of CuO doped with cadmium. And here this one is 1 weight percent dopant, 2 weight percent, and this 5 weight percent dopant. So here again in this case also, but in this case it is although the rate of increase at the output it is not the output intensity is not exactly constant, but it is slightly increasing as compared to the other one. So at the output we are getting constant output as the input intensity is raised up to certain level. but in this case it is slightly increasing. But still we can say it can be used as a optical limiter. Okay. So we have synthesized so many optical and so many nanoparticles, though with different elements and from nanocomposite with different so many polymers, and we have studied and we have presented those results. We have also studied non-optical properties in colloidal form. So these are the few results. Here is SN-DOPE CEO nanocolloidal suspension, in which we have studied the non-optical properties of this colloidal suspension. ZNO TiO2 nanoparticle nanocolloidal suspension, which we have prepared and then studied non-optical properties. CO-DOPE ZNO PVA nanocomposite thin films have been prepared. We have already discussed those. The results have been published before this one. This is ZN-SRO PVA nano composite thin films. Again, we have seen the linear and non-linear optical properties of zinc sulfide passivated with L-arginine and doped with lithium and Nd. So again, we got an interesting result in this case also. Okay, so these are the other few results which we have published. So whatever the work here I have presented, it is of my research students, Dr. Y.S. Tamgage, Dr. S.S. Tarvatkar, Dr. L. Sunatkari. Thank you. If you have any question, then you can ask or you can talk with me after this session also.
And if anyone he can ask in the session, in the continuing session also. Thank you very much, sir. Light has its own areas. Sir, your topic on non-linear optical polarization and its blending with technology enlighten us with new ways towards knowledge. The topic was very descriptive with smoother presentation. Thank you very much once again, sir.
Thank you.
And stay tuned. Okay. So moving forward, I would like to call Dr. A.M. Bagde, Assistant Professor, Department of Mathematics of late Rajkamalji Bharat, Sushilabai Rajkamalji Bharat Science College, Arni, to have an introduction of Dr. K.S. Nisar, sir, from Saudi Arabia. Over to you, sir.
Thank you very much, Dr. D.P. Deshmukh. I am here to introduce our last speaker of today's webinar, Dr. K.S. Nisar. He is Professor of Applied Mathematics at Department of Mathematics, College of Arts and Science College, Wadi, Al-Dawazar, Prince Sattam bin Abdulaziz University, Saudi Arabia. He has research interest in fractional calculus, mathematical modeling, special functions and trigonometric series and some, hypergeometric series, mathematical physics, mathematical statistics, and many more. He has done his PhD in applied mathematics in January 2011 from Aligarh Muslim University, India. He has been honored various awards like Riemann Young Scientist Awards 2020, Biruni University, Turkey, PSAU Research Excellence Award 2019, and many more. He worked as assistant professor in mathematics at College of Arts and Science, Prince Sattam bin Abdulaziz University, Saudi Arabia, from 2011 to 2016. Then he became associate professor in 2016, and presently he is working as a professor in the same college. He has completed 9 research projects sponsored by different bodies, and the total cost of the project is about 2 crore. On his account, 1 patent is credited. He has published 129 research papers in international conferences and journals. Now, I request Dr. K.S. Nisar to deliver a lecture. Over to you, sir. Dr.
Okay,
Nisar.
yes, very good morning to all. Thank you very much for the nice introduction. Audible? Hello,
Yes,
sir.
sir.
Okay.
Clear,
So, thank you very much for nice introduction. So, I am going to share my presentation instead of wasting time. So, please wait for a minute. After that, let me share my presentation here. Okay, I think now you can see my screen. Is it clear?
Yes, sir.
So actually, I am not going to present any subjective or something related to applied mathematics. I would like to share my experience because I have a good experience in publishing different field. As I published more than 500 papers and 400 papers in Web of Science with the different category journals. So this is my great pleasure to present this experience with you. And I expect this will be very worthy for all the researchers, including those who are very new in research, even for the master's students. So what's my topic today? I would like to discuss something about the scientific research skills. And I would like to explain how to write a quality research papers, how to develop your skills, and about the teamwork. So here, I would like to divide my presentation in 3 sections. First section is about the journal classification, and the second section is about the submission, means writing skills, and the third section about how to develop your skills in research. So let me start my presentation here. Actually, let me open the PPT 1 second. This is a PDF file. So let me open my. Okay. Now here you can see the outline of the presentation. Know about the journal classification, writing effective scientific research paper, journal selection, develop your skills, and the conclusion. Okay. So first, I would like to start with the journal classification. So as you know that there are different type of indexing or journal classification and ranking. International Scientific Institute involved in classification and ranking, Scopus journals. After that, we have ESCI journals, which is from the master list. So most popular classification The first one is the International Scientific Institute, that is indexed by the Clarivate Analytics. Then including the Science Citation Index, or we can say that Expanded Science Citation Index, SCIE. SCI means, those journals are available in Web of Science without impact factor. And after that, the Scopus indexing journals. So the SCIE journals is one of the ISI classification in which the journals are ranked Q1, Q2, Q3, and Q4 based on impact factors. So recently, many universities are focusing this quartile ranks. That means the first 25% is Q1, next 25% is Q2, and so on. To obtain the ranking, one may refer to Web of Science. So ESCI are the master list of journals available in the Web of Science without impact factors. To obtain the details, one can refer to Clarivate Analytics master list. So I am just beginning with the very small information and very minute information, but gradually I will bring you with how you can develop your skills. So first you have to know about the journals, then you have to know about the submission procedure, how to target the quality journal. Then after that, I will give you some tips to improve your research activities. So the Scopus is the one of the most popular database which is ranked by SJR impact factor. Scopus journals are available in all the subject area, and you can see that here we have different discipline journals available for Web of Science. To get the ranking of Web of Science, what you have to do, you have to go to the Web of Science, or you can say without institutional access, you have to open the Web of Knowledge website and just to register yourself, and you can search the ranking of the journal. Any particular journal, just you have to type the name here like this, Applied Mathematics and Computation. Then the next window will show the information about the journal. Just to click on this, then you will get to the quartile ranking. That means this journal is 7 of 260 journals. That means it will come under 25%, so it will be a Q1 journal. Now, ESCI journals is widely available in the master journal list, and it can be easily accessible through internet. Scopus indexed journal can be accessed from scopus.com, or there is a free database, that means private database called SJR. Simago.com journal rank PHP. Here you can get to the Scopus quartiles, whether the journal is Q1, Q2, Q3, and so on. So this is about the journal classification. Now I would like to explain some tips about writing an effective scientific research paper. Now you can see, I would like to discuss some common points. That means why research is important. Those who are very beginners or master students, they will get some motivation here. A tool for building knowledge and facilitating learning means to understand the various issues and increase the public awareness. Like recently, we published many papers in COVID data analysis, control, and many strategies like that. And the third point, research helps the people nurture their potential and achieve goals through various opportunities. They seek to love reading, writing, analyzing, and sharing valuable information, and the nourishment and exercise for the mind. So, these are the basic concepts or the motivation behind the research. How to organize the research paper in good form? So we are starting from here. That means you must have a comprehensive title and the informative abstract, rich introduction by citing all the related research papers based on the relevance of the topic, main results and discussion including analysis, and well-structured conclusion and well-structured bibliography. So let me give some tips about the abstract writing. An abstract is like a movie trailer. People will only consider reading the rest of the manuscript if they find your abstract is interesting. Abstract offers a preview highlights key points and helps the audience to decide whether to review the entire work or not. Abstract are the pivot of research paper because many journal editorial will consider your paper after reading the abstract only. So this is like a movie trailer. So you have to modify or you have to structure your abstract very well. Otherwise, sometimes if there is some spelling or typo error in the abstract, you will get a quick rejection. So be careful about that. Now here you can see if your abstract doesn't grab their attention and not make a good first impression, there is a good chance your research paper will be rejected at the outset. Moreover, even after your research paper is published, your abstract will be the most and the first thing the readers will access through the electronic research. They only consider reading the full manuscript after reading your abstract. So you have to modify the abstract very well. Now write the abstract after you have finished writing your whole paper. So this is one tip to improve your abstract. Second one, pick the key statements from your introduction, method, result, and discussion section to frame your abstract with the logical flow. So, many of review reports says that you must have to rewrite the abstract by highlighting your contribution. So to avoid such a type of comments, we have to plan very early. We have to pick the key statement or your real contribution and must mention it in the abstract. Now edit your abstract carefully to make it comprehensive and meet the word count requirements of the journal. Some journals are asking cannot exceed the word more than 4,000 and something like that. So you have to read the instruction of the journal before submitting the paper. Identify the major result from your result section. Now arrange the sentence and phrases into single paragraph in the following sequence: introduction, methods, results, and conclusion. So make sure that this paragraph does not contain new information that is not present in the paper. Sometimes, some papers are explaining many things in the abstract, but the content is different from the abstract. So avoid such a type of mistake. So more things you have to take care. That means undefined abbreviations or group names in the abstract, a discussion of previous literature or reference citation. So sometimes, many references can find in the abstract section. So this case, what you have to do, you have to avoid such a type of citation. You may say that XYZ et al. Prepared this or suggested this method, and we can, instead of giving the reference number, you can say something in words, unnecessary details about the method used. So you can avoid all these things from the abstract. Now link your sentences to ensure that the information flows well, preferably in the following order: purpose, basic study design, methodology, and technique used, major findings, summary of your interpretation, conclusion, and implications. So, if you focus your paper based on these points, then it will be very useful, and you have more chance to get acceptance the paper based on the structure of the paper. And of course, the content must be new and novel. Confirm that there is a consistency between the information presented in the abstract and the paper. I already said about this. Ask a colleague to review your abstract and check if the purpose, aim, methods, and conclusion of the study clearly stated. So some of your colleagues can help you to read the paper and give the suggestion before its submission. Check to see if the final abstract meets the guidelines of the journal, like word limit, type of abstract, subheadings, etc. So now revisit your abstract with these steps in mind, and I am sure you will be able to revise it and make it more attractive. Another thing you can do is go back to some of the most interesting papers you have read during your literature review. Don't be surprised if you find that they also happen to have some of the best abstract you have seen. So you can choose some best abstract and you can modify your abstract based on that. I can give you some example here. You can see this paper, a maximum PowerPoint tracking for PV system using Cocoa search with partial shading capability. The interesting thing in this abstract is you can see this clearly specified the objectives, methods, results, conclusion, and practical implications. So from here, from the abstract, everything is clear. What are the objective of the paper? What method is used or methods are used? The result, like the efficiency of the result or whatever comparison with the old literature or the existing method is given, and the conclusion says that their method is better convergence, and some practical implication also given. So from the abstract itself, you will get a full idea about the paper. So this is an example of a good abstract. Now my suggestion is that the abstract should contain objectives, methods, result, and conclusion. Also, if you are working in some engineering field, then there must be a practical implication as suggested above, but it will be better to write abstract in a single block and avoid the small titles as shown the sample abstract. So here you can see here some subtitles are there like objectives, methods, result, conclusion, and practical implication. So instead of mentioning these subtitles, you can include all these things as in a single block of abstract. It will be more attractive, because some journals, I practiced this way of writing the abstract, but some editors suggested me to remove the subtitle and compile all the sentences together. So to avoid such a type of delay, we can initially we have to be careful about such type of things. Now you can see here main body of the paper. First, the introduction must contain recent development of the subject. Cite all relevant papers. We have to credit others to giving the citation of their work. Mention the structure of the paper at the end of the introduction section. So this is about the introduction, how to structure your introduction part. The second one, the main results, that means explain all the result as much in details and easy to follow. So in main result section, what are the subsections? The analysis, conclusion. Okay, the analysis part is the most attractive part of the research paper. Give as much figures and tables for visual impact. So for engineering papers, you can see that you can put a section for numerical analysis or simulation analysis. Same that for mathematics papers also, but if theoretical paper, it will be difficult. But in this case, you can give some example to visualize your paper, or you can say that improve your analysis section. And the conclusion must be summary of the above findings. Okay, instead of writing or citing the old literature, you have to just give the short or a brief of your conclusion. I mean, a brief of your findings in the conclusion section. And the reference section, all the information must be corrected and accurate. It means there will be short form of or abbreviated form of journals, full form of journals. So you have to read the instruction of the journals, and you have to structure your reference section based on that. Now see the another one, the third part of my presentation is the journal selection and the submission. So here the aims and scope. Read the aim and scope of the journal before its submission. Structure your paper based on the aim and scope of the journal. Many times the journal returned your paper by saying that this paper is not suitable for our journal. So in this case, what you have to do, you have to read the aims and scope and prepare a paragraph to connect such a type of topic, your topic, to the scope of the journal. So you have, even you can mention this at the beginning of the introduction or at the end of the introduction section, like something we usually write in this paper. We did this and this. So you can connect your work with the journal scope. So this is very easy thing. Another thing is subject classification. Check the subject classification from the journal website, because if you can find the journal classification. In the journal means you can easily find, or the editor-in-chief can easily give your papers to the associate editor. Now another one is check the availability of editorial member from your subject area. Many journals are asking to choose the editor or chief editor to assign the paper based on the keywords. So you can refer this part also. Another one, suggested reviewers. Many of the journals are giving the opportunity to suggest the reviewer. If you suggest the subject expert as reviewers, then their comments will help to improve the paper in good form. Usually what we are doing, we are suggesting our friend's name, collaborative names, but maximum of journal says that this is the conflict of interest. So you cannot suggest the name of co-authors of some other paper. So something like that. So it will be better if you wish to publish a quality research paper, means you have to suggest the expert name as a reviewer, and their comments will help us to improve our paper. Now you can see the research motivation. The main thing is that your limitation.
Hello, Nisar sir. Hello, Nisar sir. Your audio, some problem with your audio?
Sir, Nisar sir is left the meeting, I think. They will rejoin.
Mr. Nisar, sir, you are not visible and audible.
Hello, 1 second. There is a power of 1 second. Please wait, please wait. Sir, can you hear me?
Yeah.
Yes, sir.
Sir, can you hear me?
Yes.
1 second, 1 second. There is a problem for electric power here, but within 1 minute I will be back. Sir, can you hear me?
Yes, sir.
Hello. Hello, sir. Dr. Vinod, can you hear me?
Yeah.
Sir, you are audible. Audible. Please share your screen.
Problem with power. Please wait 1 minute.
Okay.
Actually, let me connect to the network, then I will continue, please.
Yeah.
I think now it is okay. You can hear. You can see
Yeah,
the.
Yes, yes.
Okay. Let me continue. I'm very sorry for the interruption because a power problem here. Once power out means you cannot connect to the internet. Now, okay, I will be back with. Okay, so let me continue from here about this research motivation. So steps of scientific research from planning and execution. The first and foremost is formulating the research problem, the most challenging part. And you can see the research problem question, what are the points? Source for identifying the question or problem, hot topics, personal experiences, literature review, theories, ideas from others, controversies, work that challenge in common assumption. You can see this is it is not easy to manage your research without controversies, because if you are very active in your research, you will get a lot of problems from different group related to collaborative works and many things. So you have to be careful about that. And the research problem, it should be a single sentence in the form of problem. It should be a clear, unambiguous, and specific. Now, let me motivate you how to develop your skills. Okay. Actually, I need more time to explain about this part, steps of scientific research. Maybe it will take another 2 or 3 hours to complete this topic. So I think in future we can discuss this thing. So I am skipping the details about the research problems and motivation that we can discuss in another day, because today my aim is something different. Like I want to show some tips to motivate yourself. So now you can see some of, I would like to explain some of my experience here. Now you can see here. Let me start with the example identity matrix. Those who are in 11th class or 12th class, they know what is identity matrix. Fortunately, I found that many of
Nisar sir, can you share your PPT?
Oh, you cannot see? Okay, 1 second,
No,
sir.
no. Yeah.
Oh, okay, sorry. I'm sharing here now.
Yeah.
Okay. Okay, 1 second. Sir, I'm joining. 1 second.
Yeah.
Yeah. Okay. Let me share my screen.
Yes, sir. Now visible. Hello, sir. We are missing your audio.
fine, sir. Now it's fine, sir.
No, yeah, now it's
Yeah.
fine. Okay.
So I'm sorry for that. Okay. Actually, one time it interrupt means everything is damaged. Okay. Anyway. Yeah. So how to develop your skill? So I would like to start with the identity matrix. Those who are very, very basic in mathematics, those who are graduate, postgraduate, it will be very interesting for them because all these things developed by myself. You can see, about the matrices, and I connected these matrices with the optical communication. So I am gradually coming to the engineering field. And as you know that a binary code is a representation of bits and bytes or whatever 0 and 1. As a mathematician, I just want to consider this as 0 and 1. Now you can see in the engineering point of view, what they are saying. They used to say that user 1 instead of saying row 1, and user 2 instead of saying row 2, user 3 instead of saying row 3, and user 4 instead of saying row 4. So this is the language of engineers. So how to club with the mathematics and engineering, this is my motivation here, or we can say I would like to explain this. And here they are saying that the engineer is saying that this is the code word. That means here the code word is 3. You can see any user, if you take that there are 3 users, I mean code word is 3 for the 4 users. Okay. So this is the concept in engineering. So we consider this head as 1 and the circles are zeros. So from this I got some ideas how to develop my skill. So what I did first, I took some type of concept in optical communication that is called zero cross correlation, flexed cross correlation, etc. Now you can see how I developed my concept. Pascal's triangle. Everyone know Pascal's triangle, which is used to find the coefficients of some mathematical identity like a plus b whole square, a plus b whole cube, etc. So, once I saw this Pascal's triangle, I found that there are ones. So if I replace other numbers by 0, then it will be in a binary form. So what I did, I developed a matrix called Pascal's triangle type matrix, and it was developed in 2018. So what I did, nothing I did, I just removed the first 0th row. Here I called it as a 0th row. I just removed it, and the remaining I keep as it is, and I just replace the numbers other than 1 by 0. Okay. Here 2 I just put 0, 3 I just inserted 0, and like this. Now I developed this matrix. You can see here, you can see 1, 1, then diagonally it is going like a Pascal's triangle pattern. So it will look like very simple. Because everyone can do this, but this is the way of clicking ideas. Now you can see I developed some other order of Pascal's triangle matrix. Like here you can see 3 ones, then diagonally I am extending. Now I form a general form that is called n order of n cross 2n minus 1 plus 1 Pascal's triangle type matrix. So this is my contribution. I developed a generalized Pascal's triangle type matrix. Now you can see what's the application of such a type of matrix. You can see a beautiful paper here, which is published in 2018. And the name is Development and Performance Analysis of Zero Cross Correlation Code using a type of Pascal's triangle matrix for SAC OCDMA system. So, I connected my concept with the optical communication. And, as a mathematician, I have some problem with verifying my result in the lab. So I contacted the right person from Algeria. They are working in telecommunication and digital signal processing laboratory. And I just discussed that means it's a way of collaboration. You have to choose the right person to do your work. So they did the experimental work, and we published this paper in 2018. Now you can see the Pascal's triangle was invented in 1695. That means very old. But from that, I just developed a generalized form, or we can say that a binary form of Pascal's triangle. Then I got a nice paper, which is published in International Journal of Light and Optics. Now you can see another one is another form of matrix I developed that is called GMPC, Generalized Matrix Partition Code. And I got the patent for this type of development, this type of coding development. So this is very rare to get a patent in mathematics, but fortunately, what I did, here also you can see the number of users. I want to support the more number of users, and it has a good application in OCDMA system, optical fiber technology, petrochemical engineering, many fields. I found that this type of coding have a lot of potential in different fields. So here I suggested that you can extend the number of users by taking the diagonal fashion. You can see the extending the diagonal fashion. So from here, what you get, here you have different type of groups, and for different type of code weight, you are getting something like this. Okay. Now you can see from that what I published. I got a paper in 2017, and you can see the paper is numerical construction of generalized matrix partitioning code for SAC OCDMA system. Okay. So here you can see using that matrix also, I published a paper in optic in 2017, and this paper got the patent from KACST Saudi Arabia. So you can see a simple concept, a basic concept of matrices are giving a good paper in the engineering field. And this paper also published in International Journal of Light and Optics. And after that, you can see this concept is in high school level. That means anti-diagonal matrix. Anti-diagonal matrix means you have to just flip the diagonal matrix into the another form. That means you can see in the reverse order diagonal, he is here. And from this matrix, you can see an anti-diagonal type matrix like this, 1, 1, 1, 0. And from this, I just developed a technique that is called the switching. And after that, I just developed some type of coding, and I got another paper. You can see all these papers are single author paper. That means, the contribution is myself. There is no help from others. So what I did, I constructed the zero cross correlation code using the anti-diagonal identity column block matrix, and it's also published in the one of the suitable and best journal of optic. Now you can see another paper I got, and it's published in photonic network communication. Here actually we used some Boolean algebra techniques. So I got the help from my friends Himali and Simrandeep Singh. They are from Punjab, and we published another paper in Springer Journal. So this is the, now you can, while I am teaching my students linear algebra, I found one definition that is called Jordan block matrix. Jordan block matrix is very simple. In diagonal, there is diagonal eigenvalue. That means some eigenvalues and proceeding with ones. So what I did, I just replaced this lambda by 1. That means I need what? I need the binary coding. So what I am going to do, I just want to replace this eigenvalues by 1 and the succeeding rows by or columns by 0. Then I just prepared the switching circuit, something like that. Then after that, see, I got 2 papers. One is published in optical fiber technology. That we called it as DEU code. Even this code is invented by me and my friend for the SAC OCDMA system. After that, you can see we use the some analysis with the help of Boolean algebra, and we published another paper in the same year, and using the diagonal eigenvalue unity code. So this name also suggested by ourselves, because there is a diagonal fashion and there is an eigenvalue, and the eigenvalue is unity. So we just just named it as DEU. So now you can see, so these are some papers to motivate you, and recently I prepared some other papers for quality service, that is called QoS. Okay, so this quality service means how many data you want for video, how much data you want for audio, and like this, there is a separation. So recently we did some improvement in this direction also. And also now the work is in the time mode, not in the frequency mode. So we are trying to connect different concept with the different paper. Now see, my suggestion is that research is a teamwork. Okay, unity and diversity. So there is a proverb, African proverb: if you want to go fast, go alone. If you want to go far, then go together. So this is one of very motivating proverb. If you want to go fast, go alone. If you want to go far, then go together. So research teamwork is very important. Without team, you cannot do many things. So if you want some betterment, then you have to do the group work. So important of teamwork. How many of you are part of a team? Do cross-disciplinary research. What about the quality of your papers from teamwork? Have had authorship issues on papers. Now I would like to remember the words of Sir Isaac Newton. If I have seen further than others, it is by standing upon the shoulders of giants. So you can see you have to follow all these things, because then only you will be very good in research, or you can say you will be active in research with the different topics. Now you can see what is a team. I will stop quickly because I have very few more slides. So I will stop. So please. What is a team? A team means any group of people organized to work together or independently in order to cooperatively meet the needs of accomplishment, purpose, or goal. So team means together, everyone accomplishing more. So together everyone accomplishes more. That is a team. So it is recommended to work as a team to get more outcome. So here you can see this picture. This is very motivating. Many factors are needed to advance the collaborative project and manage the dispute and conflict, such as building trust, identifying the right team members, good communication, and effective negotiation. Now you can see this picture. This is saying many things, okay, without any words. This is very interesting picture. You can see this is the importance of teamwork. So success is a teamwork, and this demonstration, I think you can get it very easily. The message behind this demonstration is very important. Okay. So now you can see, finally, I would like to conclude with 2 more slides. So here I would like to quote this quote: talent wins the games, but the teamwork and intelligence wins championship. And we are intelligent, you know that we are intelligent, and we need the team. So once you have the team and intelligence means you will win the championship. So remember this word: talent wins the games, but teamwork and intelligence wins the championship. This is the words of Michael Jordan. You know that he's one of the famous athlete, I mean, in sports. So finally, not that your paper is a bride, so make up accordingly. So you just want to think that your paper is a bride. You have to make up as much as possible, because once it go, not return back until you will get a good result. So everything must be perfect at the time of first submission. Many good papers are get rejected due to bad structure and poor English language. So the paper must be well structured and error-free. Suggestion: the authors are suggested to read the aim and scope of the journal before submission. Structure your paper based on the journal demand. The paper must be arranged in simple way so that the readers can follow the result easily. If you wish to increase the citation, then you can go with the open access journal, which is openly accessible all over the world. Now the problem is that like our country, India, we have not much research support. But you know, in this case, you can collaborate with those who have projects funding from the university. So you can collaborate them. You can ask them to support the journal fee. Then you can focus this open access journal, which is quick, and also it is worldwide access, easily accessible all over the world. So your citation will increase. So that's my presentation. I hope power problem, but okay. I think now I think it's fine. If you have any question, please ask. I am ready to answer.
I think no question is there. If any question is there, we will put in the chat box.
Okay.
Nisar sir. Okay.
Yes, sir.
Yeah. Dr. Nisar sir, a million sincere thanks to you for your sea of wisdom and knowledge you have showered on us, and you taught us how to select appropriate journal and how to publish a good research paper. Sir, you are really too excellent. Thank you so much for your knowledge, what you have shared. Now going to the last lap of our program, I would like to request our beloved friend, Dr. P.M. Wankhede, to give a vote of thanks and finally declare the closure of this webinar. Over to Wankhede, sir.
Thank you, Dr. Varghese, sir. So we come to the last part of this international webinar. It's an opportunity for me to express vote of thanks for such an eminent personality who directly and indirectly help us in making this international webinar a grand success. First of all, I would like to express my sincere thanks to Honorable Dr. Sanjay Chibharti, President of Sri Datta Prasadik Shikshan Prasarak Mandal, Arni, for sharing his valuable words with us. He constantly encourages us for organizing such an events. Thank you, sir. I would like to thank Honorable Advocate Siddharth Bharti, Secretary of Sri Datta Prasadik Shikshan Prasarak Mandal, Arni, for sharing his words. Thank you, sir. I am also thankful to our beloved Principal, Honorable Dr. R.M. Tathir, sir, for his constant support and encouragement throughout this journey of organizing international webinar. Thank you very much, sir. I am also express my sincere gratitude towards Dr. F.C. Raghuvanshi, the inaugurator of this international webinar, which are working as the Dean, Faculty of Science, Santa Gadge Baba, Amravati University, Amravati, India, for being available for this event and sharing his motivational words with us. Thank you, sir. I am also express my sincere gratitude towards Dr. A.B. Lad, Chairman, Board of Studies of Physics, Santa Gadge Baba, Amravati University, Amravati, for spending his valuable time and his work with us. Thank you, sir. I am also thankful to invited speaker, Dr. Igor Nestoru, Institute of Hydrodynamics, National Academy of Science of Ukraine, for sharing his knowledge with us. Thank you, sir. I am express my sincere thanks to Dr. Abdul Hakim Deshmukh, School of Chemical Engineering and Light Industry, Guangzhou University of Technology, China, for spreading light on phosphor material. Thank you, sir. I am also very much thankful to Dr. G.G. Mure, Head, Department of Physics, Santa Gadge Baba, Amravati University, Amravati, for helping in organizing this event and deliver a nice lecture on nonlinear optics. Thank you, sir. I am also thankful to Dr. K.S. Nisar, Professor, College of Arts and Science, Wadi Al Nasir, Prince Saddam bin Abdul, University, Kingdom of Saudi Arabia, for sharing his valuable time with us. Thank you, sir. I am also thankful to dear participants, without which the program will not achieve the level of grand success. Thank you, everyone. I am also thankful to Dr. Vinod Varghese, convener of this event, Dr. D.P. Deshmukh, co-convener of this event, Dr. J.S. Kaushalya, Professor A.M. Bagde, Professor P.N. Sonone, organizing secretary of this event, and all the teaching and non-teaching staff for helping directly and indirectly for making this event a grand success. Thank you, everyone. With the permission of chairperson of this event, the program is over. The participants should submit their feedback for obtaining the certificate. Thank you. Thank you, everyone.
Thank you, Nisar.
Link is shared with your email ID. So please submit your feedbacks and collect the certificate. Thank you. Thank you, everyone.